This mat system works by creating a floating layer between tile and the surface underneath. Unlike traditional methods, it isn't glued down, which means it can move slightly without passing stress to the tiles above. This helps prevent cracks and damage caused by movement, temperature changes, or minor issues in the surface below. It's especially helpful in areas where the base might not be perfect. The mat comes in two formats: long rolls that are about 3.3 feet wide and over 65 feet long, or large flat sheets. It's around 1/8 of an inch thick. A full roll weighs close to 40 pounds, while each sheet weighs around 4 pounds. When installing, it takes just under half a gallon of mortar per square meter to fill the small shaped spaces in the mat. The adhesive layer above the mat should stay under a 1/4 inch thick. Tiles used with this system need to be at least 8 inches across, and the thickness depends on the material. Porcelain should be just over a 1/4 inch thick, ceramic slightly more, and stone at least a bit over 1/2 inch. It is designed to let any remaining dampness in the surface below escape through the joints in the tile. Its special design, with small cavity shapes and a textured surface, helps the mortar stay in place and improves bonding. Because the mat doesn't stick to the floor underneath, there's often no need to clean off all old glue or apply a primer, which can save time. Since the mat isn't attached to the base, it's easier to remove or replace the tiles later without damaging what's underneath. Germany. This formwork system uses a steel wire mesh covered on both sides with a layer of polyethylene film. It combines the strength of metal with a protective plastic layer, creating a panel that holds its shape during concrete pours. It comes in different sizes, with widths ranging from about 24 to 71 inches and lengths around 89 to 96 inches. The wires are spaced to handle different pressure levels, and panels can be delivered flat, shaped in advance, or adjusted on site. When connecting panels, a small overlap, usually around 4 inches, is used, and they're held together with wire ties or welded mesh. Once the panels are in place, concrete is poured directly against them. They don't get removed afterward, so they stay as part of the structure. This makes the process faster and removes the need to strip, clean, or store formwork after use. It's often used for foundations, edge beams, slab edges, curved shapes, and sections that need a clean break between concrete and soil. Installation begins after the foundation area is prepared. Panels can be cut or bent to fit the shape of the site, then fixed to the rebar or base using standard tools. During the pour, the steel mesh supports the pressure of the concrete. The plastic layer acts as a barrier between the mesh and the soil. Because the panels stay in place, there's no need for extra storage or return trips for formwork. They're compact, easy to move, and require no extra equipment. The plastic film includes recycled material, and because nothing is stripped away, there's no leftover waste. This Belgian system lets bricks connect without using any mortar, glue, or cement. Instead, it relies on specially designed plastic pieces that snap the bricks together from the top and sides. The bricks are made with small holes that fit these inserts perfectly, creating a clean and even look with narrow gaps between each one, about 1/8 of an inch. Behind the outer wall, metal anchors help hold everything in place by connecting it to the structure inside, like a concrete wall or steel frame. According to many, walls built this way can handle about twice the pressure of traditional brick walls. Putting the wall together is faster than the usual method because there's no drying time. Bricks just click into place, and the job can move along even if it's cold or rainy outside. It also takes less training to install, which helps save time and labor. Since there's no mortar, the bricks don't get those white stains you sometimes see from salt coming through. This system has already been used in several types of buildings, like houses, offices, and schools, covering more than 10,000 square meters across Belgium and the Netherlands. One big benefit is that the wall can be taken apart later. The bricks and connectors can be reused several times, which helps save materials and reduce waste. It also cuts down on cement use, which lowers the project's carbon footprint. In some cases, reports say this system can reduce carbon emissions by up to half. In France, they're using this mobile 3D printer for building large concrete structures directly at the construction site. So instead of assembling prefabricated parts or using traditional formwork, it creates walls, columns, and other vertical elements by layering a concrete-like material with a robotic arm. It is capable of printing structures within an area of up to 12 by 12 by 7 meters, and operates with a radial robotic arm that delivers layer-by-layer concrete construction directly on site. Its motion system allows nozzle speeds between 3.15 and 9.84 inches per second, and vertical build rates range from 11.8 to 23.6 inches per hour, depending on the material used. Layer thickness can reach a minimum of 0.2 inches, offering precision for large-scale components. The machine is compatible with pumpable concrete materials, including a proprietary mix intended for structural performance with a reduced environmental impact. It supports aggregate sizes up to 0.2 inches and allows the use of short fibers up to 1 inch in length. It operates through specialized slicing software compatible with STL and DXF files from common CAD tools like AutoCAD or Revit. Live monitoring includes a camera at the nozzle, built-in weather sensors, and real-time data tracking for pump performance. The system functions in ambient temperatures from 23 degrees Fahrenheit to 122 degrees Fahrenheit and can continue printing in wind speeds up to 37 miles per hour. Indeed, seems fine, but the promise of rapid deployment seems to apply mainly to the printer itself, not the overall job site, as it still will need a prepared, level foundation and access to power, water, and raw materials, right? Plus it works in a radial envelope, so the height for taller projects might be an issue too. Nampa, Idaho. And it really seems that in a controlled factory setting, robotic automation is reshaping how wall panels are assembled for modular construction. This system uses ABB industrial robotic arms equipped with vacuum lifters, adhesive applicators, vision cameras, and fastening tools to handle the entire process. Starting with pre-cut studs, plates, and sheathing panels, robots apply glue at specified points, position framing components into jigs, and secure them in place. Other robots then place sheathing panels, fasten them with nails or screws, and cut out precise openings for windows, doors, and electrical boxes. The equipment runs on data pulled directly from 3D models or BIM software. Design files are translated into machine instructions, guiding every robot through its tasks. Vision systems monitor alignment and placement in real time, allowing for quick corrections and high consistency. Finished wall panels are moved through the line and held in buffer zones before being sent to construction sites or assembled into full modules. This method addresses several persistent challenges in construction. It reduces the amount of material discarded during production, minimizes physical strain on workers by automating heavy and repetitive steps, and delivers higher output than traditional framing methods. ABB reports production speed improvements of up to 38% and a 30% drop in material waste during pilot projects. Other studies on automated lines suggest the system can produce dozens of wall panels per day under normal operating conditions. The system works best when wall panels follow standard dimensions and consistent layout logic, making it easier for the robots to perform their programmed roles. On-site work is still required to finish mechanical, electrical, and plumbing systems, but the majority of the structure is handled off-site. In Pennsylvania, they have this autonomous rebar tying robot named Tybot that ties rebar, reinforcing steel bars, on construction sites, especially in bridges and large concrete decks. It speeds up large construction projects, saves time, reduces physical strain on workers, and keeps the quality of the work consistent. Here's a simple explanation. When workers build a bridge or a large concrete floor, they first place a grid of steel bars to make the concrete strong. Normally, workers must tie the bars together by hand using wire. A slow, repetitive, and tiring job, but this machine does it automatically. Mounted on a metal frame that moves across the grid of steel bars. It has cameras and sensors that let it see where the bars cross each other. When it finds an intersection, it quickly ties them with wire. More than 1,200 ties per hour. It doesn't even need digital maps or programming. Once it's set up on the deck, which takes about 2 hours, it starts scanning and tying automatically. It works day or night and in different weather conditions. The machine can cover areas from about 11 to 117 feet wide, and it ties bars up to number 8 by number 9 in size. Those are standard rebar thicknesses. It uses 15-pound spools of wire and can run for around 10 hours before refueling the generator. To us, it seems fine, but maybe only for larger projects, causing smaller pours, say 1 or 2 week jobs, the payback may be less compelling. In other words, on very small jobs, the setup overhead may reduce the robot's cost or productivity advantage. Plus, it doesn't work vertically yet, so for structures with heavily sloped, curved, or vertical rebar grids, or very irregular geometries, the machine will still rely on manual labor. Annyeonghaseimnika in South Korea, and I promise it means hello. Integrated into the very fabric of a building's exterior, this solar solution replaces the conventional idea of rooftop panels with something more advanced. Building integrated photovoltaic modules. These aren't mounted on top, they are the roof and the facade. Using monocrystalline N-type silicon cells, the modules operate within a typical efficiency range of 19% to 22% based on comparable LG neon solar lines. The double-sided tempered glass construction adds structural integrity and fire resistance, while also allowing for colored finishes that adapt to architectural needs. They're built to endure harsh environments, with an operational temperature range from -40 degrees Fahrenheit to 194 degrees Fahrenheit, and front-rear mechanical load ratings of approximately 113 pounds per square foot. Though full technical specs for the ThinQ Home BIPV modules are not public, LG's other solar module lines help outline performance expectations. The system pairs with LG's Home 8 energy storage system, offering 15 kilowatt-hours usable capacity per unit and modular expansion up to around 58 kilowatt-hours. This setup is coordinated through the ThinQ energy platform, which enables AI-powered load scheduling, energy monitoring, EV charger integration, and grid interaction. This solution functions as both an energy generator and a part of the building's envelope, essentially a dual-purpose material. It aligns with South Korea's zero-energy building policies and is suited for buildings targeting net zero performance. On a systems level, it combines generation, storage, and intelligent control. Energy produced by the modules is stored and managed within the platform, which adjusts usage based on demand, weather, and user behavior. The platform supports backup power and allows interaction with grid services, making the system flexible and future-ready. And konnichiwa! We're here in Japan for a system, an autonomous haulage solution used in large-scale open-pit mining. It allows massive electric drive trucks, each capable of carrying between 220 and 440 tons of material, to operate without drivers. The vehicles move along predefined routes, controlled remotely through a central operations center. It gave us high-precision GPS navigation, onboard computers that handle steering, acceleration, and braking, as well as radar and laser sensors to detect any obstacles or vehicles on the route. It relied on wireless communication networks to maintain constant connection between trucks, support equipment, and the central control hub. Now, trucks operate continuously, day and night, without the need for driver shifts or rest periods. This consistency improves fuel use patterns and reduces wear on tires and brakes. The entire route network, loading zones, dump points, fueling areas, is mapped digitally to guide the autonomous vehicles. Technical specifications from one example truck included a gross vehicle weight of about 916,000 pounds, a payload capacity of around 507,000 pounds, and a power output of approximately 2,700 horsepower. The maximum speed reached nearly 40 miles per hour, with a turning radius of roughly 52 feet. Vehicles measure about 49 feet in length and 28 feet in width, using large, specialized tires. The system managed the entire truck fleet, not just individual vehicles, and is integrated with dispatch software to coordinate tasks, monitor conditions, and analyze performance. So all we could say was, "Kanpeki desu." It means perfect in Japanese. I hope that's what it means. Up further, we analyzed this luffing jib tower crane, towering over 720 feet. It lifted up to 220 tons and operated independently at heights over 720 feet in freestanding mode. At full capacity, it maintained a lift speed of around 20 feet per minute and offered fine control with micro-motion precision near 0.2 inches per second. Its load moment capability reached 3,300 ton-meters, providing the mechanical advantage needed for handling large-scale components at height. Speaking about a tower crane built to lift extremely heavy components to extreme heights used in the constructions like tall wind turbines, where large parts like nacelles, blades, and tower sections need to be positioned with high precision. The crane also functions effectively in locations where space and access are limited. Its footprint, about 98 by 213 feet, supports operation in narrow or remote environments such as deserts and hilly regions, where wind farms are commonly located. The structural system requires no permanent foundation and no external attachment during operation. It can be broken down into modular sections, which allows easier transport and reassembly between turbine positions, a key factor for large-scale projects involving dozens of towers. Performance in high wind areas is supported by stability features that allow continued lifting in conditions up to wind level 6 and safe standing during level 10 winds when not in use. These capabilities help reduce downtime in areas prone to changing weather. Micro rebar changes how concrete reinforcement works, not by adding steel on top, but by mixing it directly into the concrete itself. Each fiber is a twisted strand of steel, around 30 to 35 millimeters long and under 1 millimeter thick. They're added to the mix at a rate of 10 to 18 kilograms per cubic meter. Once inside, they form a dense, three-dimensional network that helps concrete resist cracking and boosts its tensile strength up to 300 megapascals. The twist in each fiber isn't decorative, it's functional. That helical shape creates a mechanical bond with the surrounding concrete, locking each strand in place. That grip helps stop cracks from growing and adds strength long after the concrete has set. Unlike traditional mesh or rebar, this reinforcement spreads out through the entire structure. The result is a slab or wall that performs more consistently and holds up better under stress. It's also easier to work with. There's no rebar to lift or tie, no mesh to position, and fewer joints to worry about. For crews on the ground, that means quicker pours and less setup. In precast plants, it can eliminate entire steps in the process. Helix performs under fire conditions too. The steel fibers stay in place when exposed to high heat, helping the concrete hold together longer. From large-scale industrial floors to tilt-up walls and residential slabs, Helix provides consistent reinforcement throughout the mix. It simplifies the job without cutting corners. Smart Slab reimagines what a concrete ceiling can be by combining structural performance with precision digital fabrication. It spans 78 square meters and is made up of 11 prefabricated segments, each around 7.4 meters long. These segments use a ribbed structure, where the ribs are 30 to 60 centimeters deep, while the shell in between is as thin as 1.5 to 2 centimeters. The entire slab weighs just 15 tons, around 70% lighter than a traditional flat concrete ceiling of similar size. The magic happens in the way it's built. The underside, full of curves and recesses, comes from 3 D-printed sand molds. These allow for millimeter-accurate detailing that would be nearly impossible with traditional formwork. For the straighter rib sections, laser-cut plywood handles the job. A thin layer of fiber-reinforced concrete is sprayed on first to form the shell. Then, conventional concrete is poured in to complete the ribs above. Once the segments are delivered to the site, they're post-tensioned together. The structure can cantilever out up to 4.5 meters with no extra support. It doesn't just hold up the floor above, it also acts as a finished ceiling below. Services like lighting, sprinklers, and wiring run through the slab, thanks to carefully planned voids and channels built right into the formwork before concrete is poured. Doka XBot Lift doesn't replace workers, it works with them. It's a robotic assistant designed to make high-rise construction faster, safer, and more efficient. Think of it as a mechanical teammate that lifts, shifts, and positions formwork panels on the Flino crane. No manual hoisting, no downtime between pours. Mounted to the climbing formwork system, Doka XBot travels vertically as the building grows. It handles wall formwork panels weighing up to 150 kilograms, moving them into place with precision. The robot uses onboard sensors and GPS-guided automation to locate exact positions, even compensating for wind or structural movement. It's not guessing, it knows where every panel needs to go. Instead of waiting for the crane to swing into place, crews can call up the robot and continue working without delay. That alone shaves hours off repetitive tasks and keeps the schedule moving. And because the robot works directly from the structure, it stays with the build, climbing floor by floor, just like the formwork it rides on. Safety gets a serious boost too. With Doka XBot doing the heavy lifting, fewer workers are exposed to high-risk zones like slab edges or suspended loads. The robot doesn't get tired, distracted, or injured. It just picks, rotates, and sets the next panel like clockwork. Structures isn't your everyday scaffolding. It's muscle for mega projects. These massive modular lifting and shoring systems are designed to handle the heaviest loads in construction. Bridge spans, offshore platforms, precast segments, and steel superstructures. If it's too big for cranes or traditional supports, Structures steps in. At the heart of the system are huge steel trusses and gantries towering frameworks that can span dozens of meters and support thousands of tons. They're fully modular, meaning they can be configured to fit the needs of each project, from launching bridge segments across valleys to lifting entire decks into position with millimeter precision. Each unit is engineered with hydraulic controls that do more than just lift, they push, pull, slide, and align heavy elements into place. Structure systems can adjust in real time, balancing loads, compensating for deflection, and syncing with sensors to track stress across the structure. It's not just brute force, it's controlled, measured strength. One of the system's standout features is the bridge launching gantry. It assembles bridge spans segment by segment, lifting from one pier and sliding the completed section forward as it builds. This method means bridges can be built without heavy ground equipment, even over rivers, roads, or deep terrain where access is limited. The equipment is made for repeat use, with a rugged design that stands up to tough weather, tight timelines, and demanding site conditions. Despite their size, the components break down for transport and reassembly on the next job, flexible enough for infrastructure teams that move from project to project around the world. Sapphire clip-on balconies make adding outdoor space feel more like plugging in than building out. These modular balconies arrives fully assembled balustrades, drainage, flooring, and all ready to attach directly to a building structure without the delays or risks of traditional methods. Each balcony is manufactured off-site in a controlled environment. That means no weather delays, tighter quality control, and quicker timelines. The units are then transported to the site and mechanically fixed to pre-installed brackets on the facade. Once secured, they're instantly functional, no scaffolding, no curing times, no need for edge protection during assembly. The real strength lies in the bracket system. It's engineered to support both vertical loads and lateral forces from wind or occupancy. Balconies can be designed to cantilever or tie back into the structure, depending on the building's frame. The fixings meet structural and fire safety standards, and because everything is tested ahead of time, there's less guesswork on site. Most systems use a hidden slope and discrete outlets to shed water away from the building, protecting the envelope and the unit itself. Balustrades can be glass, steel, or aluminum, with multiple finish options to suit architectural styles. Clip-on balconies aren't just fast, they're consistent. Every unit looks and performs the same, whether it's floor 2 or floor 20. That kind of uniformity helps with planning, budgeting, and even aesthetic approval on large developments. For developers, it means faster builds and earlier occupancy. For installers, it means less risk and less on-site labor. And for residents, it means a private outdoor space that feels solid, safe, and part of the building, not an afterthought. BaseTrack doesn't pave, it stabilizes. It's a Geogrid reinforcement system laid directly into soil to strengthen weak subgrades before roads, foundations, or embankments go on top. Think of it as giving the ground a skeleton-tough, grid-like structure that spreads loads out, reduces rutting, and keeps everything above it from shifting over time. The grids are made from high-tenacity polyester yarns or fiberglass, coated for UV and chemical resistance. They're strong in tension, but open in structure, allowing aggregate to lock into place through the apertures. This mechanical interlock creates a reinforced layer that acts more like a composite than loose fill. Installation is fast. BaseTrack unrolls over the prepared subgrade, followed by a layer of gravel or crushed stone. As the aggregate settles into the grid, it locks in, creating a reinforced platform. There's no curing, no downtime, just compact and keep building. The result is a more stable base with less material, often reducing the required thickness of fill layers by up to 50%. It's used under highways, railways, airport runways, and in embankments and retaining structures. In soft ground conditions like clay, it keeps heavy loads from punching through. In high load areas, it reduces deformation and extends the life of the pavement or structure above. What makes BaseTrack so effective is its simplicity. It doesn't require special training or equipment. It just goes in, does its job, and disappears under the next layer. But what it prevents settling, shifting, cracking, makes a major difference in performance and maintenance over time. This construction system uses interlocking, U-shaped panels made from fiber-reinforced concrete. Each panel is 2.4 meters long, and the sleeper version measures 2.4 by 0.0, 2 by 0.08 meters, weighing about 44 kilograms. It's been tested to meet Australian standards for structural loads, cyclones, fire, sound, and water resistance. Some panels come with built-in channels for plumbing and electrical services, which are added during the manufacturing process. Reinforcement can be included when needed, depending on the demands of the site. Everything connects without mortar. The dry-fit design locks panels together with grooves and tongues, so there's no waiting around for materials to cure, and bad weather doesn't slow things down. On-site work moves quickly. Builds that would normally take weeks can reach lockup in a matter of days. One example home had its structural shell finished in just 11 days. The concrete surface is smooth enough for cladding or plasterboard to go on directly, and the tight tolerances keep walls straight and clean. It works well for homes, commercial spaces, and retrofitting older buildings. The system replaces traditional blockwork, making construction up to 4 times faster and less dependent on highly skilled trades. The sleeper units are also used in retaining walls and foundations. Panels are delivered to site ready to go, and if pre-plumbed, they can reduce on-site service work by up to 70%. The tight seal between units keeps water out without the need for extra sealing materials. Already in use in New South Wales and South Australia, the system is expanding to the US and Canada. It's been picked up by industry groups and prefabrication networks, and a team of experienced builders is driving the growth across more regions. Is it possible to move entire buildings, roofs, walls, everything, without tearing them down? Using powerful hydraulic jacking systems, they can lift structures weighing hundreds of tons, inch by inch, with exact pressure control. Steel beams are slid under the foundation, supported by stacked towers of wood or steel to keep the building steady, while it's raised or rolled away. In some cases, they've lifted warehouse roofs over 18 feet to make room for new equipment inside. For projects that need new foundations, they dig out the space beneath while keeping everything above safely in place. To move a building from one location to another, they use transporters with multiple axles and steering systems that can handle tight turns and city streets. Their gear includes high-capacity jacks, thick steel beams, heavy-duty trailers, and control systems that keep everything level and secure from start to finish. They've been doing this work for over 50 years with a small, specialized team. Their reach covers the entire US from the Northeast to the Pacific Coast. Every job starts with a detailed survey, measuring the building, checking the foundation, planning the route. Once that's done, they get permits, install equipment, and begin the lift. The move itself comes next, slow, steady, and heavily monitored. Then the structure is lowered into place and checked again for level and stability. The whole process can take a few days or stretch into weeks, depending on the size of the building and the challenges involved. Costs depend on weight, distance, foundation needs, and what it takes to clear the path, things like traffic signals or buried utilities. Their work includes moving a 430-ton public library in Connecticut, raising historic homes above flood zones, and relocating buildings that others would say are impossible to move, all without losing the original structure's form or function. This single-use formwork system is made for concrete walls, where the reinforcement runs straight through without breaks. It's available in several widths to fit different wall thicknesses, all with a standard height of 1 meter. Rebar goes right through a built-in glass fiber mesh. No need for drilling or extra prep. It's nailed to regular formwork using 3.1 by 65 millimeters aluminum nails, then stabilized with a wooden wedge in the center before pouring the concrete. Once the concrete is set, the formwork stays in place and creates a clean, intentional joint between sections. It's a smart option for phased construction or spots with tight reinforcement spacing, where working room is limited. Since there's no stripping or foaming involved, it cuts down on both time and hassle. The process is simple. Nail it in, thread the rebar, stabilize, and pour. That's it. No removal or follow-up needed after the concrete cures. Because it stays embedded, it keeps the rebar path uninterrupted while clearly marking out a break line between pours. It works especially well for projects like basement walls, lift shafts, retaining walls, or other below-ground structures, anywhere the job has to move quickly, or where labor is tight. It creates solid, reliable joints without extra steps or special tools. Weighing 5,600 tons and stretching 22 meters long by 11 meters wide, this concrete bridge wasn't built in place. It was put together off-site and slid into position in a single push. 5 powerful hydraulic jacks, each about 3.8 tons, moved it forward at roughly 9 meters per hour. The whole move took just 5.5 hours, wrapping up more than a day ahead of schedule. To get the site ready, crews took out 113 meters of rail and 188 sleepers, then dug out about 15,000 cubic meters of material, including layers of tough sandstone. Around 250 workers stayed on the job around the clock to finish the move and immediately start restoring the railway. Ballast was laid back down, tracks were reinstalled, and the embankment was rebuilt, keeping rail disruption to a bare minimum. Stone shouldn't bend, but these panels do. They look like solid marble or granite. Sleek, heavy, expensive. In reality, they're high-performance composites engineered for strength, flexibility, and minimal weight. Built in layers, these panels combine natural stone or advanced surface materials with a core of aluminum honeycomb and a sturdy backing. The result? Structural cladding that's up to 80% lighter than traditional slabs, but just as stunning. Depending on the configuration, panel thickness ranges from 5.5 to 50 millimeters, with a standard 25 millimeters panel weighing just 22 kilograms per square meter. Sizes can reach up to 150 by 300 centimeters, and the system is flexible enough to wrap around curves as tight as a 50 centimeters radius. The layers are bonded with high-strength adhesive, creating panels that are both strong and durable. Impact resistance is exceptionally high, about 60 times that of solid granite, and the panels maintain excellent structural rigidity. Over time, the adhesive bond actually strengthens, reaching up to 460 pounds per square inch. These panels are built to withstand harsh conditions, meeting Miami-Dade NOA standards for wind, water, and even missile impact. They also meet a wide range of fire safety certifications. Installation is clean and efficient, thanks to a patented clip and track system that avoids the need for mortar. The panels handle large sizes and curved shapes without compromising performance. Because they use significantly less stone than solid slabs and are much lighter, they're easier to transport and install, and they help reduce environmental impact. Manufactured in the US, UK, Australasia, and China, Hi-Comb panels have been used in projects like Kensington Row in London and 321 Ocean Drive in Miami. They're a fit for everything from building facades and interior walls to furniture, bathrooms, and even vehicle interiors. Natural stone can be heavy, hard to work with, and slow down a project. This cladding system offers a smarter solution. It uses a thin layer, 8 to 10 millimeters, of real limestone, slate, granite, or sandstone, bonded to a 19 millimeters thick core made from aerated concrete. The full panel comes in at around 30 millimeters thick and weighs up to 50 kilograms per square meter, which cuts the usual weight of solid stone by more than half. Panels can reach up to 3.2 meters in length and 1.4 meters in width, covering large areas with fewer joints and cleaner lines. They attach using hidden ceramic disc anchors and clips fixed to a metal frame. That setup works well for ventilated facades and curtain wall systems, and it's just as effective indoors for decorative feature walls. It also meets Class E5 for impact resistance. Behind the panel, a ventilated cavity helps regulate temperature and reduce noise, while mineral wool insulation, types TCG032 and TCG035, adds another layer of energy efficiency. This system fits all kinds of projects: new builds, renovations, high-rises, or ground-level homes. Its size and strength support architectural details like tall vertical panels, recessed corners, spandrels, and soffits. Joints can be neatly mitered for a smooth, continuous look. A wide range of stone types and finishes are available, from polished to textured, including local and imported options. Because it's much lighter than traditional stone, it's easier to transport, lift, and install, without sacrificing the depth and realism of the real thing. It also stands up well to harsh weather and freeze-thaw conditions, while its flexible subframe can handle uneven surfaces. From exterior facades to interior walls, it delivers a solid, lasting finish with far less hassle. Each panel is molded from actual poplar or American chestnut bark, then made from a tough closed-cell polyurethane. The result is a siding that delivers solid insulation, about R4.7 per inch, and stands up to impact, bugs, and decay. It's also hand-painted with UV-stable colors that look natural and stay that way over time. There are 4 styles to choose from. The Elite series uses larger panels, nearly 29 by 17 inches, that give up to 3.79 square feet of coverage, depending on the species. It has thick texture and deep relief, with some edges reaching 3.5 inches. The Old Style series has a squarer shape, about 17.5 inches on each side, a more compact profile, and comes in 3 tones: poplar gray, earth tone, and chestnut timber brown. Slim Pro is all about speed, with thinner panels in 2 sizes: Standard, 20 by 16 inches, and Big Dan, 24 by 24 inches, which covers a full 4 square feet at once. The Patriot series mixes panel patterns to create a more random, natural look, with an easy-to-install lapped edge and a 16-inch reveal. Installation uses a system called Vapor Lock, where each panel locks into the one above it using hidden flanges. They go over rigid plywood, or OSB, with a breathable house wrap. Screws secure the pieces from behind, though a few may go through the face in specific spots. Panels need to sit for 24 hours before install to adjust. Trim corners can be boxed or mitered, and caulk helps seal the seams. Once up, the panels look almost indistinguishable from actual bark. They work on gables, walls, pillars, and even interior spaces where natural texture makes a statement. This foundation system starts with a grid of plastic waffle box forms that shape a 2-way ribbed concrete slab. Standard post-tension cables are threaded in both directions through the ribs, adding strength and helping the slab stay stable when the ground shifts. Steel rebar runs alongside the cables, held in place by special clips that lock everything into position. Once everything's set, concrete is poured in a single step, with the right cover over the cables, following established engineering codes from the Post-Tensioning Institute and the International Building Code. What makes this system stand out is how little of it actually touches the soil. Only the ribs make contact, which means less pressure from swelling or shrinking ground. The spaces between ribs let the soil move around without pushing up on the slab. By focusing the weight onto specific points, the system creates higher pressure exactly where it's needed, helping resist ground movement more effectively. The process is quick and consistent. Level the site, set the waffle boxes, secure the cables and rebar, pour the slab, let it cure, then apply tension. From start to finish, it usually takes just 3 or 4 days, much faster than typical slab construction. It's been used in everything from single-family homes to apartment buildings and light commercial spaces, especially in areas with clay, loose soil, or rock, where traditional foundations often struggle. Beyond performance, it saves on materials. The slab uses less concrete and steel, and there's less soil to haul off-site. Since it was introduced in 1993, over 30 million square feet have been installed across the US without a single reported structural failure. The Peria Public Stair is designed for real-world demands. Crowd-heavy events, public access points, and temporary structures that need to meet strict safety standards without slowing things down. It offers stair widths of 1.5, 2, or 2.5 meters, and the base footprint for a stair tower starts at 3.25 by 5.5 meters. It's rated to handle heavy use, with stairs and landings supporting up to 7.50 kN per square meters, and guardrails standing strong against 2 kN per square meters lateral force. This system fits into the existing Perry UpFlex grid and reuses most of the standard parts: decking, guardrails, base plates. So there's no need for a full overhaul. Only 7 extra parts are needed to turn standard scaffolding into a public staircase. The setup is simple. Components lock into place without tools, using a proven node and ledger system. Stair treads and guardrails secure firmly using hooks or the gravity lock. You can fine-tune the stair height in 25 centimeter steps and small changes in elevation. It works across a range of layouts, including single flights, U-shaped designs, or full stair towers, with or without central openings. It can withstand wind loads of 0.20 kN per square meters and reach up to 12 meters high under standard use. For taller builds, Perry provides structural verification. Ideal for stadiums, exhibitions, or temporary access routes, the system adapts quickly to different needs. It installs fast, integrates cleanly with existing structures, and handles the pressure of high foot traffic. Blocking sound, especially those deep, low-end rumbles, isn't something most panels handle well. This one does. Each sheet measures 4 by 8 feet, is 3/4 of an inch thick, and weighs around 26 pounds, covering about 32 square feet. It's made from dense recycled wood fiber, clocking in at roughly 14 pounds per cubic foot, with a thermal resistance of R2.45 per inch, and water absorption kept under 4%. Inside, a mix of densities and tiny air pockets help break up sound across a wide frequency range, including bass tones below 125 Hz. On its own, it offers an STC rating of about 27, but paired with drywall, insulation, and resilient channels, it helps walls and ceilings reach ratings as high as 68, depending on how it's installed. Tested to meet ASTM standards, it holds up under pressure. More than 60 pounds per square inch of tensile strength, and 20 pounds per square inch of compressive strength and minimal expansion. It stays solid and doesn't swell out of shape. Made entirely from recycled material with no formaldehyde or VOCs, it's safe for indoor use and supports green building certifications like LEED. Installing it is pretty easy. Screw it into studs or existing drywall with screws every 12 inches. Then run resilient channels across, every 24 inches on walls, 12 inches on ceilings, followed by 2 layers of drywall. Use acoustical sealant along every edge and seam to lock in performance. The dimpled side of the panel should face inward, towards the framing. You can cut it with a circular saw or a sharp utility knife. Keep the panels dry until they're in place. For electrical boxes, leave at least 30 inches between outlets, and, if needed, frame them out with panel scraps to keep sound from slipping through. Instead of digging, pouring, and waiting for concrete to cure, this system installs steel screw piles straight into the ground using a mechanical driver. Each pile is made in a factory, so every piece meets strict standards for strength and shape. The threads and helices are designed to grip the soil as they go down, locking in place and supporting a wide range of loads, from small buildings to larger infrastructure projects. Because there's no excavation or on-site mixing, the work goes quickly. Crews need less equipment, fewer steps, and don't have to deal with messy concrete or drying time. The process is cleaner and quieter, with minimal disruption to the site. It also means fewer vehicles, less waste, and a shorter overall timeline. Developed by Kibag Bauleistungen, this screw pile method replaces traditional cast-in-place concrete foundations. It's especially useful where digging is difficult or limited, like tight city spaces, areas near water, or ground that's protected for environmental reasons. In projects where the structure might be temporary or moved later, the piles can even be removed, assuming they're designed that way. Compared to the older concrete approach, which involves several stages and depends heavily on weather and soil conditions, this system moves most of the work off-site. That shift brings more predictability and consistency. On-site, it's all about speed and simplicity. One rig, one step, and the pile is in. On construction sites and in warehouses, there is a constant need to move large and heavy loads. Traditionally, this task is handled by forklift trucks. While they can both lift and transport materials, they are often bulky and costly to operate. The handtruck PT140 offers a practical alternative: compact, easy to maneuver, and highly efficient. It can lift up to 309 pounds, and the unit weighs about 97 pounds without add-ons and folds down to just 10.4 inches tall, making it easy to store in a van or tuck away in a workshop. The lift runs on a 12-volt actuator that you control with a thumb switch. An 18-volt lithium battery powers the system for up to about 50 lifts on one charge, so you can get through a typical job without swapping batteries. You can change how high it lifts by choosing different attachments. With the standard self-closing hook, it can pick from roughly 1 foot off the ground to a bit over 6 feet high. If you use the optional fork attachment, it lifts to around 5 feet. To use it, you lean the frame toward or away from the load to catch it, and then press the switch to raise or lower. For safety and battery life, it turns itself off after 10 minutes of not being used. Because it's not a full forklift, most people won't need special licenses to operate it. You can buy it for $4,500. Even the simplest lock or doorknob requires you to make a few holes in the door. Their size must be calculated with great precision. Otherwise, the knob won't fit properly or may end up being loose, which will cause problems in operation. A set for door lock installation from Lowe's company costs only $30. It will help you make a perfectly sized hole for a knob in the right place. The kit includes everything you need for the job: 2 hole saws, 2 1/8 inch for the main lock and 1 inch for the latch, a spade bit for wood, 2 small drill bits, a screwdriver bit, an arbor with a pilot bit, and the bracket that holds everything in place while you drill. The process is broken down into 3 main steps: set, drill, and install. First, you position the jig on the door. Then you drill the holes through the guides. Finally, you install the lock. One helpful feature is the auto strike locator. This tool helps line up the latch on the door with the strike plate on the frame, so you don't have to measure everything yourself. A voltage detector is a must-have tool for electricians. This model comes in at a price of $250. It can pick up electromagnetic fields from 120 volts up to 500 kilovolts. With different sensitivity levels, it can be adjusted to match the environment. The device itself is very small, about 0.40 by 2 by 1.5 inches, and weighs less than an ounce. It runs on a rechargeable battery, lasting up to 80 hours per charge. Workers can attach it to their hardhat using a clip. The Halo SL is the lighting part of the system, giving users 3 options: a 360-degree ring light with 276 lumens, a spotlight with 406 lumens, and a flood mode with 262 lumens for close tasks. It's powered by a single lithium-ion battery, with runtimes ranging from just 1.5 hours up to more than 121 hours, depending on the setting. Both devices are built tough, meeting the IP67 standard for dust resistance and protection against water immersion up to 3.3 feet for 30 minutes. The system uses a mix of lights and sounds to warn users of electrical hazards. LEDs change color and beeping speeds up as a person gets closer to danger. Yellow and red lights indicate voltage, while blue signals current. An auto-sense feature can reduce false alarms by pausing warnings if steady background fields are present, only resuming if the user moves closer. The sixth sense also includes a fall detector. It looks like the blocks are floating above the street, but it's just paint. From a distance, especially from a driver's seat, this crosswalk appears three-dimensional, even though it's completely flat. The design uses shadows, color contrast, and angled lines to trick the eye. While it might just look like a regular crosswalk to someone walking across it, drivers see something that looks like a solid object in the road, which naturally makes them slow down. Getting that illusion right takes careful planning. The lines have to be drawn at just the right angle, and the painters have to be very accurate. Even small mistakes in the shape or color can ruin the effect. It's not a quick job either. Compared to a normal crosswalk, this one takes more time and effort. The paint needs to match the road and the lighting, and the whole thing has to be seen from a specific angle to really work. This idea started in India, and later showed up in places like Iceland, Switzerland, and France. The goal is simple: get drivers to slow down near crosswalks without using speed bumps or traffic lights. And it works. When drivers see what looks like a raised barrier, even if they know it's just paint, they usually hit the brakes. The illusion only works from a certain distance and height, usually from where a driver would naturally see it. If you're standing close or looking from above, the effect disappears. But when everything is lined up just right, it's surprisingly convincing. On construction sites, paper tape is commonly used to cover and seal the joints. Its purpose is to stop cracks from appearing later on. However, there's a problem. The tape itself isn't sticky. Because of this, workers first need to spread a thin coat of spackling paste over the joint. This step must be done quickly and evenly before the paste begins to harden. In short, the process is quite demanding and requires precision. What's more, the job usually takes place in two separate stages, which makes it even more labor-intensive. The product hardened simplifies things, turning the whole task into a single step. This tool lets you apply joint compound and paper tape in one smooth pass. It's built for flat seams, butt joints, and inside corners, repeatable moves so your taping goes faster and looks cleaner. Inside the mud tube, the surfaces are hard anodized, so they don't wear down as fast and won't leave tracks in the finish. A longer, knurled grip helps you hold and control the tool. You control mud flow and tape feed with a pump-style action. There's also an adjustable brake so you can set the tape tension exactly how you like it while you work. A quick release latch makes it easy to change rolls of tape and open the tool for cleaning. Like any drywall tool, it needs regular cleaning. Drywall compound can build up inside and hurt performance, so the quick release cap helps you rinse and scrub faster. Manuals and part diagrams make maintenance and replacements easy. Fully loaded, it's not light. Long sessions, especially on ceilings, can be tiring. Hardened costs $1,500. Many high-altitude jobs, like repairing wind turbines or working on power lines, require workers to climb up and down repeatedly. The challenge is even greater, because these lines are usually suspended about 25 meters above the ground. To put it into perspective, after just 12 climbs, you'd have scaled the equivalent height of the Eiffel Tower. For a faster, safer, and more comfortable solution, you could invest $15,500 in this winch. The whole setup, including the carrying case and accessories, weighs about 29 pounds. It can lift at a speed of around 79 feet per minute and lower slightly faster. It handles up to 440 pounds, whether that's one person with equipment or just equipment alone. You can control the speed precisely, and there's even a remote that works up to nearly 500 feet away in a straight line. The device is built with smart battery controls that manage things like temperature, charging, and power flow. For more, there is an emergency stop button and a backup system that lets you lower manually if the power cuts out. How far it can lift on a single charge depends on the weight being moved and the temperature around it. In average conditions, about 220 pounds at 68 degrees Fahrenheit, it can go up around 650 feet before needing a recharge. Heavier loads shorten that range. If needed, there's an option to plug into an external power source, which can stretch the range a lot farther, up to 1,640 feet for lighter loads. Charging the battery takes about an hour and 20 minutes. It can also recover a bit of energy while coming down, though that's limited if the battery is already full. Extreme heat or cold affects how well it works, and it will automatically reduce power if it gets too hot or too cold inside. And, in Liechtenstein, I hope that I pronounced that correctly, there is this non-explosive demolition agent that, when mixed with water and poured into drilled holes, expands to safely and quietly crack rock or concrete using internal pressure instead of explosives. It doesn't use explosives, meaning there's no noise, shock waves, or flying debris. And there are two types of it. One is a liquid for regular holes pointing downward, and the other is a thicker version that can be shaped by hand and pressed into holes that go sideways or upward. The holes used are usually between 1 1/4 and 1.5 inches wide and can be as deep as 20 feet. How far apart the holes are spaced depends on their size, but a common rule is 10 times the hole's width. The amount of material you need depends on how wide and deep the holes are. For example, you'd use about 1.08 pounds per foot for a 1 3/8 inch hole. To mix it, you need around 34 to 40 fluid ounces of water for every 11 pounds of powder. A power mixer is best to get the right texture, and it's important to pour it into the holes right after mixing. Temperature makes a big difference. On hot days, cracks can appear in just a couple of hours. In colder weather, it might take 2 or 3 days though. It works best between 41 degrees Fahrenheit and 95 degrees Fahrenheit. Once the material is in place, there's no need to block the holes, but covering the surface can help keep it from drying out too quickly. Because it doesn't explode, it usually doesn't require special permits or licenses to use. Next, we have some staples that reinforce and stabilize concrete or brick surfaces by stitching across damaged areas. The company says they come in different sizes. They're sold in packs of 5 or 10, depending on the model. 3 is labeled for use in cracks that are between 0.04 and 0.2 inches wide. The measurements likely describe the size of the staple itself, or the space it covers. These staples are used to fix cracks in materials like concrete or brick. To install one, a small groove is cut across the crack. The staple is placed so that each side goes into opposite edges of the break, and then the area is filled with something like mortar or epoxy. When everything sets, the staple helps hold the surface together and keeps the crack from opening up more. This follows a method already used in the construction field called crack stitching. What seems to make them work is the combination of physical anchoring and the bonding material around them. When everything is applied properly, the result is a stronger repair that can handle some movement or stress. And the number of staples and how far apart they go depends on how long and wide the crack is, and how much weight or pressure the area takes. In Belgium, we've got a ground screw foundation system that anchors directly into soil to support decks and terraces without the need for concrete. It replaces traditional concrete footings by using a 25.6-inch long ground screw that anchors directly into the soil. There are two versions available, the 65XL, which sticks out about 5.9 inches above the ground, and the 65S, which sticks out 1.6 inches. Each kit includes 4 ground screws, top plates, adapters, extension rods, and other connecting pieces to help build a stable base. The setup allows for easy height changes and connects to wood joists or tile deck systems. After installation, the screw holds the structure steady by spreading the weight into the ground. Since it's driven into the soil instead of being set in concrete, there's no need to dig or wait for anything to dry. Once the screw is in place, you can build on it right away. The adjustable parts on top help keep the surface level, even on uneven ground. If more height is needed, extra rods can be added to lift the support higher. Everything can also be taken apart later if changes are needed without tearing up the whole area. It's useful for spots where pouring concrete might not be an option or where a more flexible setup is preferred. The XL and S versions are mainly different in how much sticks up above the ground, which affects how the other parts fit. Once the screws are in place, no drying or setting time is needed, and the rest of the structure can be built right away. Next, we go in New Zealand to see a system used to set up concrete foundations like slabs, footings, and walls. Instead of using wooden stakes and angled braces, this one also uses metal parts that you attach next to the formwork. These parts are held in place with metal stakes and then connected to the wooden boards using screws or bolts. Once everything is in place, you can adjust the height and angle using handles built into the units. This helps make sure the forms are straight and level before the concrete is poured. Some versions of the system include bubble levels to help with alignment. After the concrete sets, the metal parts and stakes are taken out and saved for the next job. Because the same parts can be reused many times, there's much less wood and nail waste left behind. People who've used the system in the field say it can cut setup time in half and make leveling up to 80% faster. Taking everything apart afterward is also quicker. Some say 60 to 75% faster. The system can reduce job site waste by up to 90%, which is useful on sites where managing leftover materials is a hassle. Using ProBrace also means less heavy lifting and fewer chances of getting the angles wrong when setting up forms. But like anything, it works best when installed properly and in the right kind of soil. In Liechtenstein, sorry for my pronunciation, working with your arms above your head for long periods can really wear you out. Wait, isn't that the same in New York too? I guess. And so this shoulder support device helps take some of that weight off by using a simple mechanical system. It doesn't run on batteries or motors. Instead, it uses springs and cables to shift some of the strain from your shoulders down to your torso and hips. That way, your upper body doesn't have to do all the work. It weighs about 5.3 pounds and fits around your upper body like a vest. You can adjust it with straps around your waist, chest, and upper arms, so it can fit different body types. The large size fits arms up to 16 inches around and is about 17.8 inches wide and 9.8 inches long. Padding in the right places helps keep it comfortable while you're wearing it for a full shift. When you raise your arms, the support system kicks in and helps hold them up. It doesn't give you extra strength, but it helps you stay in that overhead position longer without getting as tired. It's especially useful for work like installing ductwork, ceiling grids, pipes, or electrical cables. Anything that keeps your arms up for a while. Studies show it can reduce the effort your muscles need to hold your arms up by nearly half. That means you can work longer with less strain. Since it doesn't have any electronics, there's nothing to charge or plug in, and it's easy to use right away. If needed, different people on the crew can use the same unit by adjusting the fit. And in Zurich, this concrete ceiling slab covers about 860 square feet and is made from 11 separate pieces that fit together to span 39 feet. It weighs only 20 metric tons, about 70% less than a regular concrete ceiling of the same size, but it covers a relatively large area. Its thickness changes depending on where more strength is needed, going from as thin as 0.8 inches to just over 5 inches, and is made with a special type of concrete designed for digital construction and reinforced with standard steel bars. Built-in channels for air, electrical, and plumbing systems are part of the design, so there's no need to add extra ceilings to hide them. What makes this slab different is how it was designed and made. Most concrete ceilings are flat and use more material than necessary, just to be safe. This one was shaped using computer models that calculate exactly where the concrete is needed for strength. That means less material is used, and the shape naturally follows the flow of force across the surface. The result is a ceiling that's not just efficient, but also has a unique, curved look. To create the complex shape, large 3D printers were used to make the molds out of sand. These molds were made using a process called binder jetting, which binds layers of sand together to match the design. The printer used, one of the biggest available, allowed for very accurate details. Although the molds can't be used more than once, they make it possible to create shapes that traditional methods can't handle. UK, a ready-to-use channel and bracket system made to hold up pipes, cables, ducts, and other building services. The system includes a metal bracket and 2 interlocking tracks that connect without tools. Its bracket lengths range from about 6.7 inches to 57.9 inches, giving different options for space and load needs. It can safely handle around 220 pounds in one orientation and 154 pounds in another, with evenly spread loads reaching up to 440 pounds, depending on setup. This channel's main advantage is how quickly it can be installed, about 6 times faster than older systems. The bracket locks in place securely and can be moved or adjusted without using nuts or bolts. The tracks have measurement marks every 2 inches, helping installers line things up accurately. Any extra track can be snapped off instead of cut, which keeps the job site tidy and reduces waste. Once the system is in place, it's easy to make changes or adjust heights without taking the whole setup apart. There are several versions to fit different spaces. The standard version works for most ceilings, the side-loading option helps when space is tight, and the low-profile model fits shallow ceiling areas. There's also a version designed to keep power and data lines separate. Add-ons like conduit clamps, J-hooks, and vibration dampeners make it more adaptable to different projects. Each bracket can hold attachments on any of its 4 sides, giving flexibility in how equipment is positioned. The parts come packaged in a way that makes them easy to move and store at the job site. Back to the United States. To home, of course. This concrete wall system uses large, heavy blocks to hold back soil and create solid retaining or freestanding walls. Each block is made from high-strength concrete, usually rated above 4,000 psi. They come in sizes like 28, 41, and 60 inches wide, and can weigh anywhere from about 1,500 to over 3,200 pounds. There are different types, including solid and hollow core blocks, as well as special pieces like corner units, caps, and planters. The faces of the blocks are molded to look like natural stone, with textures such as cobblestone, limestone, ledgestone, and kingstone, which helps avoid a repetitive or artificial appearance. In many cases, walls can be built up to 18 feet high without using reinforcement, as long as the ground conditions are favorable. If taller walls are needed, especially up to around 21 feet, hollow core blocks can be used. For even higher walls, like those over 60 feet, a reinforced system is used. This involves inserting Geogrid into slots in the blocks, helping tie the wall into the surrounding soil. Freestanding walls, which don't hold back soil, are usually built up to about 7.5 feet high, unless extra anchoring is added. Installing these walls involves planning for things like drainage, foundation depth, and how the blocks lean backward slightly for added stability. Drainage features like gravel layers and filter fabric are included to help keep water from building up behind the wall. The blocks are designed to fit together securely and stay aligned over time. Zurich again, and a new building method from a company uses special technology to help workers place bricks or wood blocks with extremely high accuracy, down to just a few millimeters. It works by combining digital design with augmented reality, which shows workers exactly where each piece should go. A camera watches the structure as it's being built and compares what's already in place to the plan. Then it shows small adjustments to help guide the next piece. This method allows buildings to have more interesting shapes, like curves or tilted surfaces, without giving up strength or stability. Instead of building only straight, flat walls, architects can create patterns, textures, or surfaces that change with light and sound. To help everything fit, blocks are sometimes shaped ahead of time. In one example, wood pieces were cut into specific shapes to fit a sculpted wall inside a cafeteria. Another project in Greece used bricks with gaps between them to create a shifting light effect on the outside of a wine cellar. Before construction begins, architects design everything in 3D using computer software. That design is then uploaded to the system, which helps guide construction on site. Workers use screens or AR headsets to see exactly where and how to place each piece. As each block goes in, the system checks the position and gives real-time feedback to keep things on track. This way, even though people are doing the building, they get the kind of precision usually expected from machines. Back to the UK, back and forth. Joining two kitchen countertops can be tricky, but this fastener system makes the job a whole lot easier. Instead of fiddling with nuts and bolts that eat up time, it lets you tighten the connector from underneath using a drill. Thanks to its gear-driven head, you can lock it in place with one hand and get a rock-solid connection fast. It comes in different models to match various countertop thicknesses, from thin half-inch boards to those over 1.5 inches. Each version uses different bolt lengths and driver heads. The compact version, for example, has a 4-inch bolt and uses a T25 Torx bit. The standard version uses a 6.5-inch bolt and a 5mm hex bit. All bolts are made from zinc-coated steel, and some models include reinforced plates to handle higher torque when tightening. Installation starts by routing matching slots into the underside of each countertop using a jig or template. These cutouts make space for the bolt's head and shaft. Once the recesses are done, the bolt fits snugly into place. Plastic clips hold it steady so it won't fall out, and wood biscuits help line up the countertops perfectly. Then, from underneath, you tighten the bolt using a drill and the supplied bit. The gear mechanism pulls the two sections together until tight. No struggling with nuts, no awkward angles, just smooth, controlled clamping. Spain. Looking at a solar thermal system that works by turning sunlight into heat. It's designed to look just like regular slate roofing or wall cladding, so it doesn't stand out or change the appearance of a building. Instead of adding bulky panels on top of a roof, the system replaces some of the roof tiles with special slate modules that collect solar energy. The heat can then be used for things like heating water, warming rooms, or heating a pool. The system connects to regular hot water tanks and heating systems. To work properly, the roof needs to have a slope steeper than about 22 degrees, roughly a 5 to 12 pitch. Each module is made to match the surrounding tiles, so everything lines up and stays watertight. The system is modular, meaning it can be scaled up or down based on the energy needs of the home. In terms of performance, this system can supply as much as 2/3 of a home's yearly hot water demand. In real-world examples, results can vary depending on the setup and location. One project managed to cover 57% of its hot water needs and reduced carbon emissions by around 990 pounds per year. On average, every 10.8 square feet of slate installed cuts about 200 pounds of CO2 annually. Since the slate holds heat well, it also helps keep temperatures more consistent throughout the day. And an American system is made to help steelworkers safely climb up and down steel columns while staying connected the entire time. It combines 3 main parts: a foot frame that straps onto the worker's boots, a claw that grips the column, and a lanyard that ties it all together. The setup can hold up to 250 pounds, including tools, and if the worker slips, it stops the fall within 2 feet. The foot frame is made from tough steel and has a jaw that grips the column like a clamp. It works sort of like climbing stairs. Each step locks into place as the worker moves up or down. The bottom of the frame has a textured surface that helps the worker keep their footing, even if there's oil or dirt around. It straps on quickly, using strong webbing and a heel bar to keep it secure. The claw is what follows the worker as they climb. It stays in place along the column and locks in if there's a sudden drop, keeping the worker from falling too far. The lanyard connects the claw to the safety harness worn by the worker, keeping everything linked together while they move or work. This setup is mainly used during steel construction or repair jobs, like putting up columns, doing inspections, or making adjustments high off the ground. It removes the need for ladders or heavy equipment in some situations. Since it supports both feet and keeps hands free, workers can focus better on tasks like welding or bolting. Next, looking to some French fancy fences made from welded steel mesh panels. But why we're looking at them? Let's find out. They're attached to metal posts using secure clips or brackets, forming a strong and stable structure. So, not only be a nice sight with added decorative panels, but it will also be incredibly durable. The fence will be easy to maintain and even easier to install, even without any construction experience. But if you need more privacy, there are slats available in PVC, wood, or artificial greenery that can be added between the mesh. For decorative touches or extra strength, metal cages called gabions can be filled with rocks or other materials. Gates come in standard 2-panel styles that swing open from the middle, and custom sizes can be ordered. There are also a variety of parts like posts and connectors to complete the setup, and electric motors can be added to automate gate opening. By the way, gate automation has always felt so fancy, no matter French or Polish, but a solid example of gate automation is the Ontramatic Ionxbu system. It runs on 24-volt power and includes 2 12-volt backup batteries. If there's a power outage, the gate can still work using battery power. It functions reliably in temperatures ranging from 5 to 122 degrees Fahrenheit, which covers most weather conditions. Belgium again. Ever wondered what's hiding under that perfectly green patch of synthetic grass? It might be drain base doing all the heavy lifting. So there, we're looking at a smart drainage tile system designed to go under synthetic grass and keep it dry, stable, and in place. Each tile measures about 24 inches by 24 inches and is just over an inch thick. One tile covers almost 4 square feet and weighs a little over 2 pounds. It's made entirely from recycled high-density polyethylene, a type of plastic that can handle sunlight, freezing temperatures, and chemical exposure without breaking down. Every tile has more than 1,000 small pins on top that help keep artificial grass from shifting. There are also 9 flexible zones built into each tile, so it can adjust to slight bumps or dips in the ground underneath. The layout underneath follows a checkerboard pattern that spreads out weight evenly, and the pieces connect with a click system that can handle slight changes in size caused by hot or cold weather. Each square yard of the system can hold nearly 8 gallons of water before it slowly drains into the ground below. Looking closer, we see that it channels water through the turf into its grid and down to the soil, preventing puddles and adding insulation. Installation involves digging, leveling, laying a weed-blocking fabric, adding gravel, and snapping the tiles together. Tiles can be trimmed to fit and topped with artificial turf, which is secured with caps and screws. In Atlanta, Georgia, a fabric-formed concrete system, creating harsh, durable, erosion-resistant linings and structures for underwater and slope protection. It works by using specially designed fabric forms that are filled with a strong concrete mix. Once filled, the forms create solid concrete linings or blocks that take the shape of the fabric. These structures are installed directly on-site, without needing traditional wooden forms or steel reinforcements. The result is a single, continuous concrete piece shaped to fit the area where it's used. Depending on the design, the thickness can range from 3 to 10 inches, with weights between 34 and 90 pounds per square foot. Some of the largest versions, like hydrocast units, can weigh up to 70 tons. There are different types of Hydrotech systems, each made for a specific purpose. Some include built-in drainage features to let water pass through, which helps lower pressure underneath the concrete. Others, like the uniform section, form a smooth concrete surface that's good for channels or slopes. The EnviroMat types are made with gaps that allow plants to grow through the concrete, which can help blend the structure with the surrounding environment. For areas with strong waves or water movement, Hydrotech includes block-style designs that can shift slightly and stay in place without breaking apart. Some forms are made to wrap around underwater pipes or support piles. I think we know what you're thinking, but before installation, engineers often help design the right version based on local conditions, like water speed, soil strength, and slope. Each project uses forms that are adjusted to match the specific challenges of the site. A circular saw can generate noise levels of around 90 decibels, while forklifts often exceed 100. In a busy work environment, that kind of noise forces workers to shout just to be heard, and quickly leads to discomfort. To help with this, the US-based company Genetics, a leading provider of communication systems designed for tough environments, offers an effective solution. Their headsets include 2 key features that make a real difference. First, they automatically cap incoming sound at a safe 82 decibels. Second, they allow you to hear what's happening around you without having to remove them, keeping you both protected and aware of your surroundings. It uses DECT7 technology to let people talk clearly with each other, even when machines are running or the environment is chaotic. The system allows for full 2-way conversations, so no one has to wait their turn to speak. It works over distances of up to 1,600 feet in open areas and uses strong encryption to keep communications secure. The headsets come with built-in hearing protection, rated to block out 24 decibels of noise. Each ear dome has microphones that pick up surrounding sounds and mix them into the conversation, but only up to a safe level. Anything louder than 85 decibels gets reduced automatically. CommHub units support between 5 and 20 users, depending on the model. Some also let you connect phones or tablets. They offer multi-channel options and can be linked with cables for larger teams. Back in the last century, a German company surprised everyone with these hammers. They run on a unique type of engine called a free piston combustion engine. It works by igniting a small mix of fuel and air by hand. That spark creates enough energy to push a piston upward, which then drops back down and repeats the cycle. Once it starts, the motion continues without needing anything extra to keep it going. There were two main versions, one weighing around 1,100 pounds and another over 2,700 pounds. The difference in size meant they could handle different kinds of work. From lighter, more controlled tasks to jobs that needed a lot more force. What stands out most about the design is how simple it is. There aren't a lot of moving parts, which means less can go wrong, even with regular use. That's one reason why some of these hammers from the 1950s still work today. They're sometimes brought out and shown at industry events where people are still drawn to the sound, movement, and power behind the machine. These hammers were mostly used to pack down soil or press gravel into place. The machine hits the ground repeatedly, using nothing more than the power of combustion and gravity. Everything works together, the chamber, the piston, the frame, to create a strong, steady strike over and over. This is the first knuckle boom stationary laser screed machine in the world, produced by the American company Samro. The SkyScreed 25 runs on a 32.5 horsepower engine and has a 25-foot knuckle boom arm. It uses an 8-foot wide screed head that doesn't rely on an auger, which means it can move in any direction. The screed head and upper frame can both rotate a full 360 degrees. It sits on 3 stabilizers and is controlled by a wireless remote. The system includes laser-guided controls, fast setup tools, a self-leveling system, and extras like a built-in pressure washer. When transported, it measures 25 feet long, just over 8 feet wide, and almost 8 feet tall, weighing around 9,000 pounds. What makes this machine different is its ability to work on both ground-level slabs and elevated decks. That means it's not just for floors on the ground. It can also be used on upper levels of parking structures or buildings. The knuckle boom arm lets workers reach over obstacles like rebar and pipe openings, so there's less need to stop and move the machine around. In terms of how it performs, it can screed up to 5,000 square feet per hour. Floor flatness scores usually land between the mid-30s and low 40s, depending on the mix and conditions. A feature called Quick Pass helps get the concrete close to level quickly, cutting down on how much has to be done by hand. The fact that it doesn't use an auger means the screed can move freely in any direction, which helps speed up the process. The way construction materials are changing shows how the industry is moving towards smarter and stronger solutions. One example is a special type of ground grid designed to work with soil, gravel, or stone. It has a 3-dimensional structure that spreads weight evenly and holds the surface in place, even when cars drive over it again and again. Because it keeps its shape, the ground doesn't sink or shift. Another important feature is that it lets water flow through naturally instead of pooling, which helps prevent erosion and keeps the surface stable over time. This grid is made to handle pressure without losing its form. Whether it is used in areas with steady pedestrian traffic or in spaces where vehicles pass frequently, it stays firm. That reliability means the surface lasts longer and doesn't need constant repairs or adjustments. It can be used in many everyday settings. Home driveways, private roads, and walking paths are common examples. It also works well in golf courses, sports grounds, and other recreational areas where the ground needs to stay even and strong. In all of these places, the grid allows water to drain properly, so the surface doesn't weaken or break apart after rain. Earlier geogrids were mostly flat and less flexible, and while they played a major role in building roads and infrastructure, this newer design takes things further. It shows how technology has improved to meet the needs of modern projects, creating stronger and longer-lasting surfaces. Next in our lineup is the ExoHeaver Exoskeleton. It is a wearable device that helps people handle heavy tools with less effort. It weighs about 52 pounds and can support tools up to 110 pounds on its own, or up to 132 pounds when used with an extra lifting module. It's designed for workers between 5 feet 3 inches and 6 feet 3 inches tall, and weighing between 132 and 265 pounds. The system combines a solid metal frame with a small motor-powered winch that helps hold tools in place. Instead of the arms and shoulders carrying all the weight, the exoskeleton transfers it down through the hips and legs. Exomed, a company from Russia, has been developing these systems since 2016. Their goal is to reduce the strain workers face when lifting or holding tools for long periods. The Enforcer is especially useful in jobs where people have to work overhead or use heavy tools for long shifts. Unlike fully motorized systems that need a lot of power, this one combines mechanical parts with a small motor, so it's more efficient and simpler to operate. There are several other models in the ExoHeaver family. The low backer helps support the lower back during lifting or bending. The hold-upper seems to assist with arm support, though details are limited. The ExoSimple is a lighter, simpler version of the system. Each version is designed for a specific kind of task, but they all share the same idea: shift the physical load away from the upper body. The weight of concrete blocks varies according to their size and shape. Some of them can weigh anywhere from 20 to 40 kilograms, which is quite heavy. Considering that a worker may have to lift dozens of these blocks in a single day, it's easy to see why construction is such a demanding and time-consuming job. In fact, workers may end up lifting as much as 2.5 tons of material daily. To help with this, the Mule is a construction robotics device designed to make building tasks faster and easier. The Mule is a machine that helps lift and move heavy building materials, making hard jobs easier for construction workers. It doesn't replace people. It works alongside them. By holding, lifting, and guiding heavy items like blocks, stone, or precast panels, it allows one person to handle tasks that would usually need 2 people or cause strain over time. There are 2 versions of the Mule, the ML150 and the MZ100. First one runs on standard power from the job site and can lift up to 150 pounds. It reaches out 12 feet and can stand up to 20 feet tall. The arm alone weighs 870 pounds, and the full system, with its forks and base, weighs over 1,000 pounds. It stretches over 14 feet long, but can be folded down to a smaller size for transport or storage. It comes with different attachments, so it can grab various types of blocks or panels depending on the task. Meanwhile, the MZ100 works on battery power. Its battery can last up to 32 hours on a single charge, and even just 30 minutes of charging can give it a few more hours of use. It can lift up to 100 pounds and uses a belt system to move materials. This is a lithium-ion battery powered brad nailer. The American company Passload manufactures these devices. The main feature of this tool is its low weight, only 2 kilograms, and a compact size. It's made for detailed finish work like installing trim, baseboards, and molding. It uses 18-gauge nails that are loaded in a straight line, and it can handle nail lengths from 5/8 inch up to 2 inches. The magazine holds a single strip of up to 70 nails. It fires 1 nail at a time using a sequential trigger system, which helps keep things controlled. You can adjust how deep the nails go, and the no-mar tip helps avoid marking up the surface you're working on. There's also a belt hook to keep it close by when you're moving around. The tool needs both a fuel cell and a battery to work properly. The fuel cell gives enough power for about 1,200 nails before it needs replacing. It's marked with a date, and using it within 21 months is recommended. The battery runs the internal systems and can last for up to 12,000 shots per charge. If you're in a pinch, a quick 2-minute charge will give you around 200 more nails. Full charging can take anywhere from a few minutes to a couple of hours, and you can buy it at a price of $350. The unusual finish of concrete surfaces is becoming increasingly popular in construction work. There are a variety of ways to do this. One method makes this easier by using a big, reusable stencil instead of traditional stamping tools. Instead of pressing a small stamp into the concrete over and over, this stencil covers a large section at once. That means workers can move faster and don't have to spend as much time lining things up perfectly with each press. The stencil is placed carefully onto the wet concrete. Getting the edges aligned just right is important. If they're even slightly off, the brick pattern won't look right. Once everything is in place, workers roll over the stencil with special tools to press the brick design into the surface. After the pattern is set, a dry coloring powder is sprinkled on top. This powder is worked into the concrete using a trowel. It helps bring out the lines between the bricks and gives the surface a more natural, brick-like look. Then, a thin layer of wet mortar is spread over the top to deepen the texture and make the details stand out even more. The stencil is pressed one more time before it's removed. Next, water is sprayed gently over the surface to wash away any leftover material and reveal the clean lines of the pattern. The concrete is then finished with plaster and a clear glaze, which protects the surface and gives it a smoother appearance. Dismantling old floor tiles is usually a long and time-consuming process. Workers use a variety of tools, such as rotary hammers, drills, chisels, and hammers. Besides, it's a rather dangerous process too. The craftsman has to spend a long time in a room filled with construction dust, large pieces of tile, and cement. Like all the other tools shown in today's video, Ripper Stripper is designed to make the work of builders easier, faster, and safer. There are several models to choose from, depending on the size of the job. Blade sizes range from 5 inches to 18 inches wide. Some models are handheld for smaller spots, while others are walk-behind or self-propelled for larger areas. All of them run on electric power, and the bigger ones use stronger dual motor systems. Each machine comes with sharp, heavy-duty steel blades that are made to last longer. These blades are heat-treated and come with a coating to help them hold up better over time. They're also marked with helpful information on how to use them correctly. Some models use the same blades, so it's easier to manage parts without needing a different one for every machine. For bigger jobs, the FCS18 is the heavy-duty option. It has a wider blade, self-propelled drive, and a frame designed for continuous work. It's meant for high-use settings and can cover large floor areas in less time. You can buy Ripper Stripper for $1,800. Microsoft has a reputation for broadening its business ventures. One of its latest steps was the acquisition of Activision Blizzard. Alongside this, the company also unveiled mixed reality glasses designed for use in construction, which we'll look into now. The system comes with a 2K display and a wide 43-degree field of view. It uses transparent lenses, so users can see both the real world and digital content at the same time. For tracking movement and position, it has 4 visible light cameras and 2 infrared cameras for eye tracking. It also includes a depth sensor that helps it understand space and distance. There's an 8 megapixel camera for photos and video, which records at 1080p. For communication, it uses 5 microphones and a bone-conductive headset that lets users hear clearly in noisy areas without blocking their ears. It connects through Wi-Fi and Bluetooth and includes 64 gigabytes of storage. The whole setup weighs about 2.75 pounds. This device is mainly used on construction sites or industrial locations. It combines Microsoft's HoloLens 2 with a safety hardhat, so workers can see 3D models and building plans directly overlaid on the actual work site. This helps them check if things are in the right place, catch problems early, and measure parts of the job with accuracy. Using Trimble Connect for HoloLens, teams can share files, make notes, and hold live meetings between the field and the office. It supports files like Revit and SketchUp, and it can lock digital models to real-world surfaces. This makes it useful for walkthroughs, inspections, and spotting mistakes before they become bigger issues. Work-related injuries don't just hurt people, they also slow down productivity, costing the US about $21 billion every year. On top of that, nearly 1 in 5 construction workers report experiencing severe pain. It's clear that the strain on workers is too high. That's why companies like Exo0G are stepping in. Their innovative robotic arm is designed to take the weight off workers' shoulders, making it easier to lift tools and heavy loads without the same physical toll. The person using the tool declares that it feels like it's floating. There are 2 versions of the system, one meant for aerial work platforms and another for scaffolding. The aerial model weighs about 34.8 pounds, and the scaffold version is around 35.4 pounds. Both can hold tools weighing up to 36 pounds and are designed to be mounted in under a minute. Once installed, the arm connects to the tool through a docking ring, a receiver, and a rotation lock pin. These parts let the worker keep the tool steady, rotate it, or remove it when needed. For overhead or vertical work, extra straps and slings can be used to provide more control. The system supports a range of heavy tools, including grinders, rotary hammers, impact wrenches, rivet busters, demolition hammers, and chipping hammers. Getting a surface ready before painting or adding a finish is one of the most important steps. This tool brings together 3 different wheels that each do a specific job to clean up surfaces like metal, wood, and plastic. The first is the eraser wheel. It's made to take off stickers, decals, tape, and glue without scratching the surface underneath. Instead of grinding it down, it rubs the material off gently. That's helpful when you're working on areas where the finish still matters. The next is the stripping wheel. This one handles tougher stuff like old paint, dirt, and oxidation. It works on different materials and removes layers that might stop paint or coatings from sticking. It clears things fast, but doesn't damage what's underneath. Then there's the wire wheel, which takes on the hardest jobs. It has stiff metal bristles that knock off built-up coatings like varnish or layers of old material. It doesn't grind away the surface or change its shape. It just clears off what's on top. That makes it good for parts that need a deep clean, but still need to stay the same size and shape. Woodworking machines are dangerous and can cause injury even if you're very careful. This is because the saw sometimes exerts too much force on the workpiece. It bounces aside, and inertia can push the palm of your hand right under the blade. You can use the gripper to avoid such problems when working with wood. It's produced by Microjig. It's noteworthy that it doesn't affect the quality of work either. The device weighs 1.8 pounds and measures 6 by 8 by 2 inches. It works with material from 1/4 inch up to 5 inches wide and fits common machines like table saws. The Safe Rip Kit adds a simple visual aid. Measuring stickers and clear orange cursors help set the fence and the center leg, so the blade path stays clear. This reduces the chance of placing the center leg too close to the cut line. The center leg moves to match different stock widths, so it can guide both the keeper piece and the offcut at the same time. The balance support sets to the workpiece thickness, helping the device stay upright and square as it moves. On the bottom, a green tread grips wood, composites, plastics, and even aluminum. If dust builds up, a quick clean brings back traction. 3 forces act together: down to hold the board on the table, in toward the fence to keep alignment, and forward to feed the piece through the blade or cutter. This robot is designed to save time and effort by getting digital layouts onto the floor 10 times faster than a human. It can draw in widths from 0.07 to 2 inches and keeps its print head about 3/4 of an inch above the surface. It connects wirelessly with surveying tools from brands like Leica, Topcon, and Trimble, which help it stay on track while it moves. The robot can handle surface bumps up to about 3/4 of an inch and works on slopes up to 2.5 degrees. It weighs just less than 20 pounds, and with its case, it's closer to 39 pounds. It runs on batteries that last around 4 hours each, and 2 can be swapped to cover a full work shift. Instead of using tape measures and chalk, this system takes a digital design file and prints it straight onto the job site floor. The layout starts in a CAD file, which is prepared using a special HP plugin. That plugin helps define what should be printed and where. After uploading the file to HP's cloud system, an operator at the site can pull it up using a tablet or phone. To begin, a survey tool called a Robotic Total Station is placed on site and linked to the robot. That connection helps the robot know exactly where it is and where it needs to go. It moves by itself, avoids obstacles, and can find its way again if it temporarily loses connection. Operators can choose exactly what to print, whether that's lines, labels, or alignment points. The way a room feels often comes down to the surfaces you see every day. Materials that add texture can completely change the atmosphere. 2 interesting options show how design can be combined with function: faux brick wall finishes and Portherm ceramic blocks. Both bring practical solutions while also adding something special to the space. Creating a faux brick wall starts with some careful planning. The wall is marked to show where each brick will go, and thin tape is placed in a grid to look like mortar lines. Over that, a layer of easy stone plaster is spread. This plaster, made in Turkey, comes as a dry powder and only needs water to be ready. Once it is applied, the surface can be shaped to look like brick, stone, or concrete, depending on the style you want. When it dries, the tape is removed, leaving behind clean lines that look just like real mortar joints. The finished wall has the texture and depth of exposed brick, giving the room an industrial feel without having to rebuild anything. This half-face respirator is designed to help protect against dust, debris, and other airborne particles. It uses a large filter surface to make breathing easier and helps you speak more clearly while wearing it. Even with the visor attached, it weighs less than 6 ounces, so it doesn't feel heavy on your face. The part that seals around your face is made from soft medical-grade silicone, which feels comfortable even if you're wearing it for hours. The straps can be adjusted in several places to help it fit different head shapes and keep a tight seal. There are two types of filters available. The FA95 blocks more than 95% of particles, and the FA100 can filter up to about 99.9%. These filters are designed to block solid particles like dust, but they aren't meant for gases, fumes, or paint sprays. The clear visor can be removed without taking off the mask. It helps protect your eyes from flying particles and splash, and it doesn't fog up from your breath. In user tests, the filter showed low airflow resistance, which means it's easier to breathe in and out while wearing it, especially useful during physical work. The company says the mask is made in North America and follows Canadian and US medical safety standards. It is priced $59. Built with strong rare earth magnets, this wristband keeps bolts, nuts, and screws right where you need them, saving you from constantly reaching for tools. Klein Tools, dedicated to crafting professional-grade tools since 1857, brings you this handy, reliable wristband. It measures just over 13 inches long, 4 inches tall, and less than an inch wide, and it weighs about 4 ounces. The outside is made from a tough woven material that can handle daily wear, while the inside has a soft mesh lining that feels more comfortable against the skin. Inside the band are strong, rare earth magnets that can hold onto small metal parts like screws, nails, wire nuts, or drill bits. It's made to keep the parts you're using right where you need them. Instead of carrying screws in your hand, stuffing them in a pocket, or digging through a pouch every few minutes, you just stick them to the wristband. That can make a big difference when you're up on a ladder or working in tight spots, where dropping pieces can be a real hassle. The magnets are strong enough to hold several small parts at once, which can help speed things up during jobs like installing cabinets, wiring outlets, or building frames. You don't need to charge anything or figure out how to set it up. Just wrap it on and start working. This handy accessory is available for $19. Installing laminate panels on a wall using an aluminum frame is a neat and reliable way to finish a room. The process starts by attaching metal guide rails to the wall. These are spaced about 19.7 inches apart and must be lined up exactly straight using a construction level. Getting this part right is important because it keeps the wall panels even and flat. Once the frame is in place, the laminate panels are clipped onto the rails. An aluminum trim is added around the edges to give the whole wall a clean, finished look. Compared to regular PVC panels, this type of laminate is stronger and holds up better against bumps and everyday use. It also helps block out sound and can keep the room a bit warmer, which is useful in both homes and offices. Since it doesn't need glue, the panels can be removed or replaced more easily without damaging the wall underneath. Cleaning the surface is easy. Unlike wallpaper, which can tear or stain, laminate panels can be wiped down with common cleaning products. The smooth finish doesn't trap dust or dirt, so it stays looking good with very little effort. Using the same kind of laminate on the wall as on the floor can make a space feel more put together. And because the panels are attached to a frame, rather than directly to the wall, the surface stays flat and even. There's also a small gap behind the panels, which can come in handy for hiding cables or adding extra insulation later on. A competition is a stage where skilled individuals showcase their abilities to prove they are the best in their profession. But it's not only athletes who seek recognition and rewards for their talent. In this case, we're looking at a construction contest, organized in 2017 by the Mason Contractors Association of America. The video highlights a speed challenge in which participants race to place breeze blocks. Only the finest craftsmen were selected to take part in this unique tournament. Breeze blocks, also known as concrete masonry units, are easy to recognize by their geometric patterns and rough surface. They're used in both structural and decorative ways, like in fences, walls, and partitions. Each block has to meet certain strength standards, with most able to handle about 1,900 pounds of pressure per square inch. Depending on the mix, their weight can vary quite a bit, which affects how well they insulate and how heavy the wall gets. Most blocks have hollow spaces, or special shapes that let you add steel bars and grout for extra strength. When it's time to build, everything starts with the bottom row, which needs to be level and straight. Builders usually start by putting up the corners first. This gives them a reference point to keep the rest of the wall aligned. The rest of the blocks are filled in row by row. Mortar, about 3/8 of an inch thick, is used between each block to hold them together. Steel bars can be added horizontally or vertically, and the hollow parts of the blocks are filled with grout to lock everything in place. Control joints, small gaps, are added every 24 to 25 feet to help prevent cracks as the wall expands or shifts over time. Here's an interesting product from Italy. A local company produces high-quality work shoes with a stylish design. Crafted from calfskin, a Gore-Tex membrane, and fiberglass, these boots may evoke thoughts of a sports car. Yet, they come at a reasonable price of around $270. In return, they offer puncture protection, impact and fuel resistance, and a waterproof, breathable membrane lining. Instead of regular laces, it uses the BOA fit system, which lets you tighten or loosen the fit quickly using a dial, especially useful when you're wearing gloves or need to adjust it often during work. Inside, there's a Gore-Tex lining that keeps water out while still letting your feet breathe. It also has Thinsulate B600 insulation to keep your feet warm in cold weather. Under the foot, a flexible textile layer helps prevent sharp objects from piercing through the sole. The bottom of the boot is made of two parts, a cushioned midsole and a tough rubber outsole. The outsole uses Vibram Fire and ice rubber, designed to grip well in both hot and freezing conditions. It stays flexible even when temperatures drop or rise sharply, and can handle heat up to about 572 degrees Fahrenheit. It's also made to hold traction on slippery surfaces, like metal or tile. The materials hold up well against things like oil and chemicals. Meanwhile in Taiwan, so one and everyone. And this is a large fabric tube, used to separate water from mixtures like sludge, sediment, or slurry. It's made from woven synthetic fabric, usually polypropylene or PET, that lets water pass through while trapping solids inside. The fabric is strong, resistant to sunlight, chemicals, and biological decay, and holds up well in wet environments. The tube works by pumping the wet material into it. As the tube fills, water filters out through the fabric and the solids stay inside. Over time, the contents settle and dry, reducing in volume. The solids can later be removed, repurposed, or disposed of. The system can be made in different sizes depending on the needs of the project. For example, one tube used in a sludge project measured 69 feet around and 98 feet long. Its volume capacity can exceed 1,700 cubic yards, much more than a traditional drying bed. The fabric is engineered to strike a balance between drainage and solid retention, allowing fine particles to stay in while water exits. Openings in the textile are small enough to prevent material loss, but large enough to support fast drainage. In some cases, additives like polymers are used to help the particles settle more quickly. This setup is used in places like harbors, mining sites, and farms to manage sediment or waste efficiently. It handles large volumes and can be placed in various types of prepared ground or containment zones depending on site needs. further, Canada! In a precise 3-day lifting sequence, a 30,000 square foot concrete structure rose into place through the tilt-up construction method. The building is composed of 25 site-cast concrete wall panels, totaling 17,371 square feet of surface area. The largest panel measures about 856 square feet, the tallest reaches 28 feet, and the heaviest weighs around 73,500 pounds. All panels were prepared and cast directly on the site floor slab before being tilted upright with a crane. The project included both insulated and non-insulated panels, with the insulated portion covering the full perimeter to achieve stable thermal performance. Tilt-up construction operates by forming each concrete wall horizontally on a flat surface. Reinforcing steel bars are placed within the formwork, along with inserts for lifting and permanent connections. Once the concrete has cured, the crane raises each panel to a vertical position and places it onto its footing. Temporary steel braces keep the walls in place until the roof framing is attached and the building becomes self-supporting. This method allows large wall sections to include window and door openings, architectural grooves, and insulation layers during casting, eliminating the need for external fabrication or long-distance transport. Each panel carries both structural and thermal functions. The reinforcement grid controls cracking and supports loads from wind and seismic forces. Insulated panels use a sandwich system of concrete, rigid insulation, and another concrete layer, creating continuous insulation across the wall without thermal breaks. Embedded plates and connectors provide precise alignment during assembly and secure attachment to the roof and floor systems. The entire lifting operation was completed within 3 days, demonstrating a coordinated workflow and high productivity. And then, in Italy, they use this modular formwork system to create an empty space beneath concrete slabs and foundations. It also provides a route for mechanical, electrical, or plumbing lines. It consists of plastic base plates, vertical plastic pipes, and top modules that lock together to form a grid. Once assembled, concrete is poured over the structure, creating a solid, reinforced slab that rests on the vertical supports. The space underneath remains open. The materials include about 97 to 99% recycled polypropylene for the formwork, and a mix of PVC and calcium carbonate for the pipes. So that air gap beneath the slab remains ventilated, and that gap helps reduce soil gas buildup, allow airflow, and separate the concrete from cold or damp ground. The structure can support loads up to roughly 20,480 pounds per square yard, depending on how thick the concrete slab is and how it's reinforced. The main components include square base plates and domes, each about 22.8 by 22.8 inches. The height of the void can range from approximately 28 inches up to 118 inches, depending on how long the vertical pipes are cut. The pipes are 5 inches in diameter and support the slab above. This setup replaces traditional fill methods, requires no special equipment, and is installed by hand before pouring concrete. It is used in both residential and industrial construction where a ventilated or raised foundation is needed. Seems quite promising, but this method may reduce shear strength, lower stiffness than solid slabs, higher initial cost, certainly takes more time, and depends heavily on precise design and installation to perform as intended. Geogrid. In Ireland, there we analyze this modular arch bridge system made from precast concrete blocks. Each block, called a voussoir, is joined with a flexible layer that supports them during transport and installation. Once in place and filled with material like gravel or concrete, the arch acts as a single structure, carrying loads through compression, similar to traditional stone arches. The system doesn't need complex temporary supports during construction. Instead, it can be delivered in flat sections, assembled quickly on site, and backfilled in a single day. The result is a bridge that combines modern construction methods with the load-bearing principles of masonry arches. Adding to this that this setup supports installation in new builds and upgrades to existing structures. The concrete used in the arch blocks typically reaches strengths of around 50 megapascals, supporting long-term use with minimal material degradation. Tests show the structure can carry loads up to 74 tons once assembled and filled. Span sizes tested at approximately 16 to 49 feet wide and up to 10 feet high. As for our thoughts, the system's limitations include untested performance under foundation scour, maybe the sensitivity to backfill quality, and the need for heavy lifting equipment due to the high weight of individual arch units. Plus, there's limited public data on dynamic or seismic loads. And in US, there's this high-output machine used to manufacture round concrete pipes using a bidirectional roller head system. It covers pipe diameters from 8 to 84 inches and lengths up to 12 feet, depending on the model selected. A36, A48, A84, etc. The system's core mechanism drives the roller head in both directions, which improves concrete compaction and helps produce consistent pipe surfaces. It includes a revised drivetrain with 6-inch chrome guide tubes and PTFE bearings, contributing to stability during operation and reducing internal wear. The top table now moves independently of the crosshead, which shortens drop time and helps increase. The turntable's reduced diameter allows faster rotation, and its two-piece design supports drop-in bottom centering plates for better alignment during setup. The optional Edge automation platform uses an Allen Bradley PLC and HMI interface, giving operators access to production data remotely. The material hopper keeps a continuous flow with air vibrators, dual gates, and a sensor system in the Edge variant to detect loss of feed. Main motor output on the crosshead reaches 200 horsepower at 3,600 RPM. The hydraulic unit supports 60 horsepower with a tank volume of about 200 gallons. Packer shaft speeds vary from 75 to 375 ARPM, based on earlier specifications. Hopper volume measures around 4.6 cubic yards, allowing steady material input during production. There are a few things to keep in mind though. Example installation requires a substantial pit foundation, including power and hydraulics. Changeovers and mold, window or tooling compatibility must be managed carefully. And choosing the correct model size is important to avoid under or over capacity. Next, in England, they have this 8-meter electric bumper, a machine that helps move building materials like roof tiles, bricks, and tools from the ground up to higher levels, such as scaffolding or rooftops. Speaking about 1,000 roof tiles in just 25 minutes. How about that? It reaches up to about 23 feet and uses a belt system powered by a 110-volt electric motor. The belt moves at around 66 feet per minute, and the hoist can carry up to 176 pounds in total, though each individual load on the belt should be no more than 44 pounds. To use it, workers set it up at an angle against a building or scaffold. Materials are loaded onto the belt at ground level, then carried up to where the work is happening. If any materials need to be brought back down, it works in reverse just as fine. This feature helps reduce trips up and down ladders or scaffolding, which can save time and effort. Setting it up takes a bit of planning. It needs to be placed securely, the angle adjusted properly, and the power supply connected safely. It's usually a two-person job to position it, though using lifting equipment might make it easier. The hoist is controlled by a handheld remote, so the person operating it doesn't have to be right next to the machine the whole time. As per our thoughts, it does make some noise though. Over 75 decibels precisely, so ear protection might be worth considering. In Poland, they say dzień dobry in Poland, and there they're using a modular building system made up of prefabricated units, or modules, that are constructed in a factory and then transported to a construction site. These modules are built to connect side by side or stack up to form complete structures, such as homes, offices, or apartment buildings. Each module is self-supporting and strong enough to handle transportation and lifting by crane. In a typical example, 3 modules combine to form a 2-story building measuring about 12 feet in width, 38 feet in length, and offering around 1,000 square feet of usable space. The factory production process includes electrical, plumbing, and climate systems, which are mostly installed before the modules leave the facility. Up to 95% of the building work is completed in the factory. While the modules are being made, groundwork like foundations and utility connections can be done on-site. Once the modules arrive, they are placed and connected quickly, which helps reduce overall construction time by as much as 70% compared to traditional methods. An online tool is available to customize building layouts, allowing selection of roof type, number of stories, module grid, and overall size. The system also supports energy-efficient features such as integrated solar panels, battery storage, and smart control systems for building performance. Overall seems okay, but this method might bring troubles with transportation. Moving large, fully built modules requires special logistics, which can increase costs, limit design dimensions, and complicate delivery depending on the location. Ahoy! In Czech Republic, arched steel buildings use a smart construction method where the curved steel ribs form both the structure and the outside shell. There's no real limit on how long the building can be. It can keep going as long as needed by adding more sections. One big advantage is that the weight of the building spreads evenly along the ground, which makes the foundation simpler. Often, a concrete strip or a flat base like asphalt is enough. Once the base is ready, steel coil is fed into a forming machine that curves it into shape. These ribs are then lifted and connected to form the full arch. Straight steel pieces are used at the ends of the building, and doors, windows, or light panels can be added there. For airflow and daylight, there are options like roof vents or skylights. Insulation can be included using thick layers of mineral or basalt wool to help control temperature inside. These buildings go up fast. Say a 5,400 square foot hall can be finished in just a few days, and even larger ones in under a week. They also cost much less than brick or traditional steel buildings. With the right materials, they last for many years and don't need much maintenance. To us, this technology, by the way, is called K-span, while efficient, can face challenges, including complex structural analysis due to non-standard curved profiles, vulnerability under extreme snow or wind loads, dependency on skilled labor and proper equipment for assembly, and even potential transport or handling issues with larger spans or unusual site conditions. So, yes. Next. Namaste from India, and looking at a robotic machine as it navigates construction floors, laying blocks in sequence with minimal human input, on a pace roughly 10 times faster than conventional masonry methods. You can move it across standard building floors and pass through doorways quite easily, and it automates the wall building process using common block types, including larger formats up to 24 inches, and its operation is based on data received from the project's digital layout. It applies cement mortar and places each block in position, following digital building drawings that guide its movements and account for wall features like windows and doors. Each step of the process is tracked, producing block-level information useful for monitoring progress, planning material supply, and reviewing construction stages. This type of system responds to key demands in construction, particularly where skilled labor is limited and timelines are tight. For building teams already working with digital plans and block-based designs, it fits within a workflow that favors pre-planning and layout consistency. Tasks such as detailing, joint finishing, and non-standard features still require manual work, but for wall assembly itself, the machine offers a repeatable and measurable approach to construction. We observed the system working in real construction environments, placing blocks efficiently, and adjusting to the wall blueprint, which removes the need to pause for each wall opening. And it seemed like was capable of anything a site worker is, except for whistling at women passing. Just kidding, of course. To us, this machine might struggle with complex layouts, needs well-prepared sites, and may offer limited cost benefits on smaller or non-standard projects. Further, we're in UK. They have this material, which is a type of concrete that includes added fibers to improve its durability through three-dimensional reinforcement. Instead of relying only on traditional steel bars or mesh, this concrete mix contains tiny fibers, either synthetic or steel, that are spread evenly throughout. These fibers help hold the concrete together once it starts to crack, improving how it behaves under stress. The fibers come in different types and sizes, depending on what the concrete is being used for. Synthetic fibers are often about 2 inches long and made from polymer materials, with tensile strength around 65,000 pounds per square inch. Steel fibers are also around 2 inches in length, but have higher tensile strength, reaching up to 210,000 pounds per square inch. The dosage range typically falls between 34 and 67 pounds per cubic yard, depending on the load-bearing requirement. These fibers don't increase the initial strength of the concrete, but become active once cracks form, controlling their spread and helping the structure keep its shape and function. The amount of fiber added depends on the project, ranging from about 5 to 10 pounds per cubic yard for synthetic fibers and up to 67 pounds per cubic yard for steel fibers. As an opinion, I don't know how they manage fibers that may stick out from the surface after finishing. Does that mean extra time for smoothing? Plus, as long as I am concerned, in environments with high chloride exposure like marine settings, steel fibers may corrode over time, which can cause staining or long-term durability concerns, even though they are often less exposed than traditional steel reinforcement. Grußgott, Austria. Concrete structures can be formed using a method where the mold continuously moves upward while the concrete is placed. This process is called slip-form construction. In this system, aluminum panels are used to shape the walls, and their contact surfaces are covered with stainless steel. The result is a solid, uninterrupted structure shaped in one upward movement. The stainless steel lining also helps maintain dimensional precision during repeated use. This system is modular, fitting different floor plans and structure types. It is often applied to vertical elements such as lift shafts, stair enclosures, and high retaining walls. These panels are attached to a support framework that includes hydraulic jacks, which gradually lift the formwork as the concrete hardens. Platforms for workers move along with the form, giving constant access for reinforcing steel placement, alignment checks, and finish control. Construction starts with the assembly of formwork on a base slab. Once reinforcement is in place, concrete is poured to an initial height. After it gains early strength, the formwork begins to move upward at a pace matched to the hardening rate of the concrete. The process continues in a continuous vertical progression, which reduces construction time by avoiding stops between sections. Embedded items, like service boxes and openings, can be integrated using aluminum inserts that fit into the panel layout. The concrete surface formed through this method is uniform and joint-free, which increases structural performance over time. Since the form does not need to be taken apart and reassembled between stages, the overall work sequence becomes more efficient. Guten Morgen in Germany. Looking at a tunnel boring machine, an advanced piece of excavation equipment designed to dig through soil and rock while simultaneously constructing the tunnel lining behind it. It is used on the high-speed rail project between London and the West Midlands, represents some of the largest and most technically specialized in operation today. Each of the main machines, including Florence and Cecilia, measures roughly 558 feet long and weighs about 2,200 short tons. They feature a rotating cutter head with a diameter of 33 feet, powered by motors delivering up to 5,000 horsepower and torque of around 12 million pound-inches. These specifications allow the TBMS to handle complex geological conditions, particularly the chalk and flint of the Chiltern Hills. Excavated material is removed via conveyors or pipelines, and precast concrete lining is installed in rings behind the cutter head and sealed with grout. These machines can advance about 50 feet per day, launched from shafts as deep as 72 feet. TBMs on HS2 vary in diameter from 28 to 33 feet and are customized for local ground conditions. In the Chiltern Tunnel alone, they placed over 56,000 segments per tunnel and handled about 2.6 million cubic yards of spoil. Their precision and ability to operate continuously enhance safety and reduce timelines. TBMS also limit surface disruption, making them essential to building high-speed rail infrastructure efficiently and sustainably. Again in Germany, and there's this jet grouting, the specialized method for improving soil conditions underground, using high-pressure jets to break up and mix the soil with a cement-based grout. The process forms in-place soil cement columns with specific strength and permeability characteristics, often used where structural support or water sealing is required. Technically, it achieves drill depths up to 131 feet and column widths between 2 to 10 feet, depending on ground conditions and tooling. Pressures involved range from 5,000 to 9,000 psi. The hardened columns offer compressive strength levels from 290 to 1,500 pounds per square inch, while their permeability can be as low as 10 to the negative 9th meters per second, meeting demanding geotechnical needs. Equipment used for jet grouting varies in size, from compact setups to large rigs weighing around 66,000 pounds. The method starts with a borehole drilled to the planned depth. Once at depth, high-energy fluid jets activate, breaking apart the surrounding soil while injecting grout into the loosened zone. As the drill string is slowly withdrawn and rotated, a cylindrical body of soil and grout forms, which hardens over time. This results in improved soil behavior without needing excavation or removal of existing material. Jet grouting is especially relevant in locations where structural elements must be stabilized below ground level, or where water needs to be blocked, such as underneath slabs, around tunnels, or at foundation bases. It has been used for foundation reinforcement, excavation support, and constructing cut-off barriers that limit fluid migration. Though it involves advanced equipment and careful engineering, jet grouting enables precise control over underground soil performance and structure interaction. To us, it remains an important option in projects where conventional methods cannot meet performance or spatial constraints. Gruisch Sack, Greisax, Switzerland. This is a professional survey drone with a wingspan of about 4.1 feet and a total takeoff weight of around 11 pounds. It can carry payloads up to 2.7 pounds and uses 2 lithium polymer batteries for power. Its main communication range extends up to 6 miles, with an optional cellular connection for extended missions. It lifts off like a quadcopter and then transitions into forward motion, allowing it to cover wide areas in less time than typical drones. Its configuration is known as a tail-sitter VTOL, enabling it to operate in confined spaces without the need for a runway. The drone has a flight speeds can reach up to 49 miles per hour, and it performs reliably in wind conditions up to 27 miles per hour. A launch and landing area of around 6.5 by 6.5 feet is usually sufficient. As a key feature, they see its ability to swap payloads without tools. These include high-resolution RGB cameras, up to 61 megapixels, multispectral sensors, telephoto lenses, and LiDAR scanners. Depending on the sensor, the drone can achieve ground resolution as fine as 0.2 centimeters per pixel and map up to 1,360 acres in one flight. It supports high-precision GNSS post-processing for sub-inch horizontal accuracy without needing multiple ground control points. Obstacle sensors, geofencing, and a dual battery system add safety and stability. The drone is intended for use in mapping, inspection, and environmental data collection tasks that demand accuracy and scale, Is it just me, or it's a bit too fast for certain detailed inspection work? Goedenavond, Netherland. There's this interesting material, a type of concrete that can repair its own small cracks without human intervention. It uses a special mix that includes bacteria spores, nutrients, and a mineral-based carrier. These components are blended into fresh concrete or used in repair mixtures for existing structures. The bacteria inside remain inactive until a crack forms and both air and water enter the damaged area. Once triggered, the bacteria feed on the nutrient and produce calcium carbonate, a mineral similar to limestone, which fills and seals the crack from the inside. This process helps prevent further damage and extends the material's usable life. It can close cracks up to about 1 millimeter wide on its own. There are a few forms available: an admixture added to fresh concrete during mixing, a one-component cement-based mortar used for surface repairs, and a liquid version for injecting into existing cracks. This self-repair system does not change how the concrete sets or gains strength during curing. It functions in structural parts such as walls, floors, and foundations, particularly in areas where keeping water out is important. While the healing reaction only begins when air and water reach the crack, the material can reduce long-term maintenance and repair work. In some cases, it may even allow engineers to use less steel reinforcement because the concrete itself helps keep cracks under control. Next, we were in Portland to see an augmented reality platform used on construction sites to view 3D building models directly overlaid onto the real environment. It works by taking models from widely used design software and converting them into a lightweight format that can be viewed through AR headsets, or in some cases, mobile devices. The system lets users walk through a construction site while seeing full-scale digital models aligned with the physical space around them. The AR display uses a wireframe or edge overlay to make sure users can still see their surroundings clearly. The model can be aligned on-site in a few steps without needing complex setup, using visual markers or QR codes when necessary. The alignment system includes rotation, location, and fine-tuning through anchors. Models are stored on the device, allowing use even when there's no Wi-Fi or internet connection. Different layers of the model, such as plumbing, structural, or electrical systems, can be turned on or off. Users can also access details about components by selecting them within the AR view. The system supports capturing observations, photos, and notes, which are tied to specific locations in the model. These can be used for inspection, verification, or coordination with other teams. It supports large models by compressing them into a format optimized for performance. And our thoughts on where just, oh wow. Doesn't this remind you Iron Man using augmented reality holograms to walk around, inspect, and modify 3D models of his suits, buildings, and tech in his workshop? And ni hao here in China. We see this prefabricated steel structure used as a hangar or large industrial building. They measure approximately 195 feet in length, 64 feet in width, and 28 feet in height, cover around 12,735 square feet, and use about 92,000 pounds of structural steel. It handles wind speeds up to 89 miles per hour and meets seismic conditions up to magnitude 7. It's made primarily from strong, factory-produced steel components that are delivered in parts and assembled on-site. The building is designed to cover a large, open space without needing interior columns, making it suitable for housing aircraft, machinery, or equipment that requires clear movement space. The frame is made from structural steel sections, mainly hot-rolled or welded H-shaped beams with high yield strength. Secondary components, like purlins and bracing, are made from slightly lower-grade steel. Roof and wall panels are either single-layer corrugated steel or insulated sandwich panels, depending on the needs of the space. These panels can range from about 2 to 6 inches thick. Steel members are treated with either paint or galvanization to resist wear from exposure. Assembly is done using pre-cut, pre-drilled steel parts and high-strength bolts, which speeds up construction and increases accuracy. This type of building is typically used in aviation, manufacturing, logistics, or storage, where open interior space is important. To me, steel structure hangers offer wide open spans and fast assembly, but they can face issues like rust in humid environments, poor insulation without upgrades, and reduced strength in high heat unless fire protection is added. So, yeah. Next in Washington, there's this project that of a large educational campus built using a construction method called cross-laminated timber, CLT, a type of engineered wood. CLT is made by stacking layers of lumber at right angles and bonding them together to form large, solid panels. The campus includes 2 connected school buildings, both 2 stories tall. The structure uses approximately 203,000 square feet of CLT for its flooring and roofing systems. The panels are supported by glue-laminated timber beams, with exterior and interior walls made from a mix of tilt-up concrete and wood framing. CLT panels are strong in multiple directions due to their cross-layered design. They are pre-cut and pre-drilled off-site, which helps speed up installation and reduces material waste. In this project, more than 800 uniquely shaped panels were installed, some spanning long distances between beams or walls. The design leaves much of the wood surface visible inside the buildings, creating a warm, natural appearance. Technically, the structure is classified as Type 5B construction and meets fire and structural safety standards. Although specific panel thicknesses are not listed, similar systems typically use panels with 5 to 9 layers, depending on the span. The use of mass timber in this project reflected a move toward modern wood construction methods that offer structural performance, efficient installation, and a distinct visual style. Now we know that a composite reinforcement method is changing how concrete structures are strengthened and repaired. So again with fibers, and this time in US. Speaking about carbon fiber fabrics or strips combined with a resin system, creating an external layer that works together with the existing concrete to improve its structural behavior. Americans are using these fibers in buildings, bridges, marine structures, and other infrastructure projects with a tensile strengths between 3,000 and 6,000 megapascals and stiffness values of 230 to 350 gigapascals. Elongation at break generally falls between 1% and 2%, while the resin, often an epoxy, offers tensile strength of 40 to 80 megapascals and a modulus of 2 to 4 gigapascals. Cure time depends on temperature, usually ranging from 24 to 48 hours. This method can increase flexural strength by 20% to 100%, and shear strength by 30% to 60%, depending on the original structure. When wrapped around columns, the carbon fiber wrap improves confinement and ductility, especially important in seismic zones. The system also helps control cracking, which can extend the life of the structure. Installation begins by cleaning and preparing the surface, filling cracks, and grinding or blasting the area down to solid concrete. A primer is applied to create a strong bond. The carbon fiber strips or fabric are cut to size, positioned on the surface, or wrapped around structural elements like columns, then saturated with resin to create a continuous bond. After curing, the result is a new external reinforcement that significantly increases the member's capacity. So, just wow! isiZulu from South Africa. I've been told that this means hello, so let's hope for the best. We analyzed this yellow machine, and is a heavy-duty articulated dump truck used for hauling large loads in mining, construction, and earth-moving environments. Mining? South Africa? What does that remind you? Its power output ranges from 210 kilowatts to 430 kilowatts, depending on the model. Torque on smaller models reaches 1,150 Newton meters at 1,200 to 1,600 revolutions per minute. Transmissions are fully automatic, offering 6 or 7 forward gears with torque converter lockup. Fuel tanks hold up to 79.8 US gallons, and additional 9 US gal AdBlue tanks support emissions control. Tires are typically 23R, 25 radial types. Dump body volumes reach approximately 19 cubic yards, with programmable tip angles near 70 degrees. Its fully loaded weight can exceed 121 pounds. This type of truck features an articulated steering frame and central oscillating joint, allowing flexible movement across soft or shifting ground. High flotation tires, combined with automatic traction control and electronically managed differential locks, improve stability and handling during transport. Next, we're in Italy analyzing a bathroom system, but I don't feel like saying, "Ciao, don't know why." We throw a dice, and it landed in a fully assembled bathroom unit made off-site and delivered as a single module to be installed directly into a building. It arrives with all the internal systems already in place, such as plumbing, electrical wiring, drainage, tiling, lighting, and fixtures, so it only needs to be connected to the building's utilities once on site. There are 2 main construction types. One uses a galvanized steel frame combined with composite panels, forming walls that are about 3 inches thick. The other is made entirely from lightweight concrete, with walls and floors approximately 2 inches thick. Both versions are finished with a layer of ceramic tiles around 0.4 inches thick. In the concrete model, the entire shell is reinforced with steel mesh to provide additional strength. Floor structures can be very slim, starting at just under ½ an inch, or made from a concrete base that's 2 inches thick before tiling. Materials used in both versions are selected for their strength and resistance to water. These bathroom units are typically used in buildings with many repeated layouts, such as hotels, apartment complexes, hospitals, or dormitories, where consistent quality and fast installation are important. Each unit is designed to fit the space exactly and can be finished with different styles, fixtures, and layouts depending on project needs. Because they are built in a controlled factory setting, these units allow for more accurate construction and quicker installation compared to building bathrooms on site from scratch. In Germany, they showed a hydraulically operated self-climbing platform used for constructing concrete cores in tall buildings. It moves upward as a single unit, lifting not just the formwork, but also the working platforms and any attached equipment in one continuous motion, without needing a crane for each repositioning. It's made to handle tall, reinforced concrete walls, like elevator shafts and structural cores. The system operates using hydraulic cylinders, each capable of lifting up to 40 metric tons. It can rise nearly 16 feet in a single lift, and a full lift cycle typically takes about 20 minutes for one floor level. Wall heights supported range from approximately 9 to 16 feet. The platform comes with large working areas that allow space for materials, rebar, and concrete placing booms. This setup enables workers to pour slabs and walls during the same cycle, which can speed up construction. Up next in Norway, this is a type of concrete roof tile used to cover and protect sloped roofs. It has an S-shaped curved profile that helps guide rainwater off the roof and gives it a smooth, structured look. Made from molded concrete, it's built for use in climates with changing weather and is commonly used in both new buildings and roof renovations. The tile measures about 16 inches in length and 13 inches in nominal width, with a coverage width of roughly 12 inches. Each tile weighs approximately 10 pounds, and you'll need around 10 tiles to cover 1 square meter of roof area. It can be installed on roofs with a slope as low as 15 degrees, as long as the rest of the roof system supports it properly. The tile has a special surface treatment that reduces the growth of algae and helps protect it from sunlight. Color options often include black, red, clay red, and grey, allowing for some variety in appearance. As for the thoughts, I don't know. The weight. Isn't that a bit heavy for a roof tile? Plus, on very shallow roof slopes, water shedding may be compromised. i.e., if the slope is below the manufacturer's recommended minimum, risk of leaking may go up. Did anyone use so far? Dzień dobry. Here in Poland, looking at this modular construction system designed to deliver fully formed building units that arrive on site with up to 95% of the work already completed. The structure uses a steel frame and composite envelope with carefully layered insulation and finishes, engineered for high energy performance and environmental resilience. Module sizes typically span 10 to 13 feet in width and up to 49 feet in length. That matches standard transport dimensions. Say a 2-story setup, for example, can cover over 1,000 square feet of usable space. Each module includes pre-installed mechanical, electrical, and plumbing systems, along with interior partitions, windows, and cladding. The building system uses layered assemblies of EPDM membranes, PIR, and PUR insulation, cement-bonded boards, and vapor barriers to improve thermal efficiency and airtightness. Modules rest on point supports, reducing foundation time, and can resist wind speeds over 170 miles per hour. Factory production cuts material waste to 5 to 7% and lowers CO2 output by up to 45% compared to traditional methods. This approach reduces site labor and speeds up timelines. Overall seems okay, but this method might bring troubles with transportation. Moving large, fully built modules requires special logistics, which can increase costs, limit design dimensions, and complicate delivery depending on the location. Blanka Permatop Wall is where heating meets design, right on the wall. It's a radiant heating system that integrates directly into vertical surfaces, offering a clean, silent, and invisible way to warm a space from the sides instead of the floor. Instead of ducts or bulky radiators, this system turns walls into active heat sources. The core of the system is a modular panel made from expanded polystyrene with integrated grooves. Flexible PEX pipes snap into those grooves and carry warm water through the wall's surface. Once installed, the panel is covered with plaster or another wall finish, leaving no visible components. Just warmth, radiating evenly. It's designed for low temperature operation, typically between 30 degrees Celsius and 40 degrees Celsius, making it ideal for use with energy-efficient heating systems like heat pumps or solar thermal setups. Despite the low temps, it creates a comfortable radiant effect, heating the room evenly without blowing air or stirring up dust. One of the key advantages is response time. Because the pipes sit just beneath the surface, the system reacts quickly to thermostat changes. It also saves space, freeing up walls from bulky heating units and floors from embedded tubing. Installation is streamlined, panels are lightweight, easy to cut, and can be fixed directly to drywall or masonry. The modular layout allows for custom pipe spacing and routing, which means it can adapt to nearly any wall configuration. Corners, edges, and even sloped ceilings aren't a problem. Some building systems try to hide how they work. Emmadu panels do the opposite. They wear their structure proudly. At first glance, it's a sandwich of wire mesh, foam, and concrete. But that combo does more than it looks. It delivers strength, insulation, and speed in one shot, straight from the factory to the job site. The core is an expanded polystyrene panel, usually 60 to 100 millimeters thick. On either side is welded steel mesh, connected by diagonal trusses every few inches. Once on site, the panels are assembled into walls, floors, or roofs, and sprayed with 2 layers of concrete. That's where the magic happens. The concrete bonds to the mesh holds to the foam, and the whole thing becomes a rigid, structural element. Despite being lightweight before spraying, the system performs like solid concrete after curing. Walls meet seismic and hurricane-resistant specs in many regions. The insulation core keeps buildings thermally efficient, helping reduce heating and cooling loads. Fire resistance? It's built in. Acoustic performance? Surprisingly high, thanks to the density of the concrete skins and the buffering effect of the foam. Construction moves fast. The panels are prefabricated to size, so there's minimal cutting or trimming. 1 or 2 workers can carry and position each one by hand. After installation, all it takes is a concrete layer and finish coats, and you've got a full wall, ready for paint or cladding. Origami structures don't just fold for fun, they fold with purpose. Inspired by the ancient art of paper folding, these architectural systems take flat, rigid materials and shape them into forms that expand, collapse, and support real-world loads. What starts as a sheet becomes a shelter, a surface, or even a structural core with strength built into every crease. At the heart of these systems is geometry. Each fold adds stiffness, allowing thin materials like aluminum, polymer sheets, or even lightweight composites to act like beams or trusses once deployed. The act of folding transforms flexibility into rigidity. Some setups open like a fan, others pop up like an accordion, but they all use motion to create structure. The big advantage? Portability and speed. These structures are compact in transport and fast to deploy. No cranes, no foundations, no heavy lifting. One moment they're flat-packed, the next they're standing tall, covering space or supporting weight. That makes them ideal for emergency shelters, mobile workspaces, exhibition pavilions, or anywhere quick setup is key. They're not just temporary either. With the right materials and locking mechanisms, origami structures can be semi-permanent or modular, growing with need or folding back when the job is done. Some even integrate solar panels, insulation layers, or acoustic treatments into the folds, proving that form doesn't have to sacrifice function. Designers and engineers use digital modeling to perfect each crease, ensuring that once folded, the system delivers not just shape, but strength. These models account for material thickness, bend tolerance, and connection points so everything folds smoothly and locks precisely. System 3 builds walls the way kids build, with blocks fast, clean, and without mortar. This construction system uses large, hollow ceramic blocks made from expanded perlite. They click together with precision-fit joints, forming structural walls without adhesives, cement, or even finishing layers. It's all about tight tolerances and a material that does more than one job. Each block is lightweight for its size, yet strong enough to bear loads in single and multi-story buildings. The perlite base gives it natural insulating properties, so walls don't need additional thermal layers. The blocks are also vapor permeable, helping regulate indoor humidity without trapping water inside the structure. The real game changer is the dry stacking. These blocks are machined to such precision that they fit together snugly without gaps. Workers simply stack them, level them, and keep building, no waiting for mortar to set, no mess, and almost no waste. Once up, the walls don't need plaster either. The surface is smooth enough to paint or apply final coatings directly. That speed has serious advantages. Crews can build entire home shells in days instead of weeks. No mixing, no downtime, and fewer tools needed on site. It's quieter too. Less noise, less dust, less disruption. The blocks are fire resistant, frost-proof, and dimensionally stable. They perform well in both hot and cold climates, and they don't shrink or swell with moisture changes. Because they're modular, they also make repairs or alterations easier down the line. Mapigwad system is the kind of protection you don't think about until water gets where it shouldn't. It's a waterproofing sheet membrane made for tile installations in wet areas, like showers, bathrooms, kitchens, or even steam rooms. But unlike messy liquid coatings, this system goes down clean, fast, and secure. The membrane is made from a multi-layered composite, a non-woven polyester fleece on both sides and a polyethylene core in the center. That sandwich construction gives it strength, flexibility, and a reliable moisture barrier. It comes in rolls, is light to handle, and cuts easily with a utility knife. Once unrolled, it's applied directly to the substrate using a modified thin-set mortar. The fleece bonds tightly to the mortar, creating a strong mechanical grip. Seams are overlapped and sealed with MapeGuard WP adhesive or banding tape, making the whole surface watertight. Corners, edges, penetrations, and all. The real advantage? Speed and consistency. There's no waiting for curing or second coats. As soon as it's down and sealed, tiling can begin. That's a game changer for pros trying to shave hours or even days off a project timeline. MapeGuard WP isn't just for floors either. It's rated for walls, ceilings, benches, and any detail that needs waterproofing before tile goes on. Once installed, it stays hidden beneath the surface, doing its job quietly. It blocks water, controls vapor, and protects the structure below from slow, silent damage. No cracking, no peeling, and no surprises years down the line. Bison Level Up Deck are about getting flat, stable surfaces, no matter what the ground throws at you. Whether it's a rooftop, sloped concrete, or an uneven patio base, this system lets you install raised decking without digging, pouring, or leveling the surface underneath. The secret? Adjustable pedestals that lock in height with precision, creating a floating platform above whatever's below. Each pedestal adjusts from as low as 1/8 inch to over 36 inches tall, depending on the model. Twist the collar and the pedestal rises or lowers, holding its position without slipping. Integrated shims fine-tune the slope up to 1/2 2 inch per foot, so you can flatten out anything from a gentle tilt to a full drainage slope. The result is a level surface fast, repeatable, and tool-free. These pedestals support a range of surface materials: wood tiles, concrete pavers, stone slabs, or even composite decking. They create a clear space underneath for airflow, drainage, and electrical or plumbing lines. In commercial rooftop decks or high-end terraces, that hidden gap becomes a game changer. No water pooling, no trapped debris, and easy access to services if anything needs repair. Installation is simple. Lay out your grid, adjust the heights, and drop in the decking. There's no mortar, no adhesive, and no damage to the surface below. If the layout changes or tiles need replacing, just lift and swap. No demo, no drama. What makes Bison stand out is how it turns rough, irregular substrates into usable, elevated platforms, clean, level, and ready to finish. It's not just a support system. It's a fast track to usable space where nothing seemed buildable before. Some solutions are invisible by design. Kobiak's SL is one of them. On the surface, it looks like a solid concrete slab. But inside, it's hollowed out with high-performance plastic voids that reduce weight without sacrificing strength. The real trick is that you never see it working, yet it reshapes how slabs behave from the inside out. Each slab includes a grid of hollow spheres made from recycled plastic. These are encased in steel cages and placed between 2 layers of rebar before the concrete is poured. The result? A two-way reinforced slab that uses up to 35% less concrete by volume while maintaining the same structural performance. That means fewer materials, lower dead loads, and longer spans with thinner slabs. Less weight on the structure opens the door to leaner columns, reduced foundation loads, and even fewer support walls, creating more open space for architects to play with. But Kobiak's doesn't compromise on safety. It complies with Eurocode and other international standards for fire resistance, vibration control, and seismic behavior. It also plays well with standard construction practices. There's no need for special equipment or unique installation techniques. The cages are lightweight, easy to place, and come in several sizes to fit various slab thicknesses, from slim 20cm decks to 50cm structural floors. What you're really getting is efficiency hidden in plain sight. Every slab with Kobiaks inside looks and feels just like a regular concrete floor, but it performs better. It's lighter, it spans farther, and it uses fewer raw materials, which makes it more sustainable without changing how crews build.